Welcome to Intellipaat Statistics for Data Science Full Course, your complete tutorial to master the most important pillar of data science, statistics. If you want to become a data scientist, here's one truth you can't ignore. Statistics is non-negotiable. That is why we have created the Statistics for Data Science course designed for absolute beginners who want to build strong foundation that lead to real-world data science jobs. Let's face it, machine learning, AI, even deep learning, all of it stands on the shoulder of statistical thinking. And in this Statistics for Data Science tutorial, you will not only learn theory but apply statistics principle practically to different problem statements. So you're not memorizing anything here, you're solving data problems, hands-on using stat and little bit of Python. In this Statistics for Data Science full course, we will start from scratch. You will learn what is statistics in data science, descriptive versus inferential statistics, mean, median, mode, variance, standard deviation, probability theory and distribution, binomial, normal, Poisson, hypothesis testing, p-values, confidence interval, z-test, t-test, ANOVA. We have also included hands-on coding implementation of these stat concepts, their real-world example and job-focused explanations. So you will know exactly why you are learning each concept and how it is used by data scientists in companies like Amazon, Google and Netflix. By the end of statistics course for data science, you will be ready to take a day at machine learning and make sense of numbers and figure out the patterns between them. So let's get started.
So stats is basically a branch of mathematics, right? So how can I give this answer is stats is a branch of mathematics which deals with collection, analyzing and interpreting large amount of data. So if we have a smaller, like suppose if I'm having a company and I have only 10 employees there, so I can easily manage the data myself. I do not need any tools or something to manage it. But if I'm having large amount of data, that time it is difficult for me to manually analyze the data. So that's why we need the tools of stats. Now the next question which is asked is, like, okay, we understood what is statistics, but why it is important for us? Why is statistics important for us? Being a data analyst or being a data scientist, why it is important? So, guys, everybody knows what is the difference between a raw data and information. Everybody knows what is the difference between these two terms. Raw data means meaningless data, right? Which do not have any meaning. And information means meaningful data. Yes or no? So, don't you think so? Your statistics is actually helping you to convert your raw data into information. Don't you think so, guys? So, with the help of statistics, we are actually converting our raw data into information. Also, we can say that, also we can say that stats allows us to derive knowledge from large data sets, that we are deriving some knowledge from large data sets, and this knowledge can be used to make predictions, decisions, etc. So this is how we can answer this question. So, okay, that we are deriving knowledge from large data sets and which helps me to make predictions, decisions, and all other things. So now we understood that our data science or data analyst field is full of analysis, analyzing the data, doing predictions, finding something, and all that stuff. So, and stats also have the quality to do that. So, how much important this concept is for us, right? I hope you got a basic idea about this. So, now let us start with the another topic, which is population versus sample. Okay. So, first, let me explain you in a layman language what exactly population and sample is. Now, suppose we live in a planet of Earth, right? Suppose this is your Earth. If I want to divide this Earth into subparts, then I think continents. So, how many continents we are having? That is 7, right? So, I divided this Earth into 7 different continents, right? That means the entire entity what we are talking about is population, the entire entity, and the sub part of that entity is known as samples. Now, how we can talk about when we have a data frame that the entire data set what we are having, the entire CSV file what we are having is the population. And if I take sub part of that data, if I take the sub part of that data, that will be our sample. So, like how we do it in real life, like suppose you have some employees data, okay, all employees data. So, all the managers, all the HRs, all the interns, all the senior employees, everyone have the data here. And from this, your question is you need to find what is the average salary of a managers in the company. So what you will do is you will filter out the data in which you will have a sample only of managers. And from this data, you will find what is the average salary of managers. Clear? Now the question arises, if this part is clear, the question arises is how do we choose samples? Okay, we have some techniques, guys, through which we decide samples, and that techniques are known as sampling techniques. So there are many sampling techniques, but three most important sampling techniques which we are going to discuss. Okay, so the first sampling technique is known as random sampling. Okay. The second sampling technique, which is known as stratified sampling. And the third sampling technique is known as systematic sampling. So I will give you a hint and you will tell me about these sampling techniques, guys. The thing is, when you face interviews, it's not important that you heard about all the concepts, all the terms there, right? There might be some new terms which will come in interviews, but according to the name, you need to answer something. It's very bad if you're sitting blank in the interview. So at least you need to say something. So let's practice that thing. Okay. So first we will talk about random sampling. So from the name itself, random, I think it's easy. What is random sampling? So yes, means taking data randomly, right? So nothing, no pattern, nothing. just randomly I will select. Like suppose from the entire school, you need to randomly pick 5 students, irrespective of what class they are, what gender they are, what age they are. You're just randomly picking 5 students, right? Second is stratified sampling. Now, from the stratified word, I think a strategy, English word strategy comes into my mind. So, what could be this stratified sampling? So, don't you think so? The example which we took above, that from the entire employees data, I want the sample only of managers. So, because I was having a strategy in my mind, my problem statement was I need to find the average salary of managers only. So when I was creating sample, I was thinking that only managers should come in my data. So don't you think so? This example is of stratified sampling, where I am putting the condition that designation of that employee should be of managers only. So I'm putting some conditions here. So stratified sampling can also be known as conditional based sampling, where you are putting some conditions. So it is the process of dividing your samples in layers or groups with some strategies. Clear, guys? So I'll give you one more example. Like from the entire data set of all the genders, I want to create a sample of women's only. The third is systematic sampling. So from the word systematic, a systematic order comes into my mind. Yes or no? A systematic order. It is ordered based sampling. Ordered based, what does it means that? Like you are creating a sample, okay? You are creating this sample, and in the sample, you are saying that I want taking every nth element. Every nth element. What does this means is, like suppose in your data points are segregated like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You are creating a sample in which you are saying, I want every third element. Every third element. So, what points you will get in your sample is, I think, 3, 6, 9, 12. So, you will be having a sample in which you will be having the points 3, 6, 9, and 12. So, a order is maintained in this type of sampling. Yeah? Okay, let me make it more clear by giving you the exact difference of three of the sampling techniques. Okay, so suppose you have a data in which the points are stored like this: male, female, male, male, female, female, and male. Suppose like this the data is arranged. So if I want to perform random sampling here, so in the random sampling, I can get anything. I can even get males. I can even get females. Anything I can get. Right? If I'm doing stratified sampling, in stratified sampling, I am saying that I want only females. Only females. So only females data I will get. Number of females present, I will get only females data. Now, if I want to do systematic here, in systematic, I am saying I want every second element. So what elements I will get is, first I will get female, then I will get male, Then I will get again few. So like this, I will get the data. Getting the difference between three of the sampling techniques. Now my question to you is, you need to find in real time what is the use of these three sampling techniques. So I'll give you one example of systematic. Okay. So in systematic, suppose you're working in some factory. Okay. And you are there, product management. You're a manager of the products there, and you want to see the production of the products. Now, see, like if any new product is launched, like if we talk about iPhones. So, recently, which iPhone is launched? iPhone 15 was launched. Now, when this iPhone 15 was launched, do you think they will produce lakhs of products? Do you think so? That they will produce 1 lakh, 10 lakh, or even crores of products at one go? Which usually they don't. Why? Because they will first create some samples. Like suppose, uh, this is not the estimate number. I'm just giving you an idea. Like suppose they will bring 10,000 phones in the market, and they will see what is the sales of this 10,000. If the sales is high, they will produce more phones. If the sales is low, they will slow down the production. That's how any industry works. Now see, from that 10,000 phones, what they have buyed or what they have basically made, do you think so? They will manually check each and every product that that is working fine or not? No, that they will convert this into batches. Batches means batch one, maybe of 500 phones, then 500 phones, then 500. From this 500 phones, so suppose this is your population now for 500 phones, and now from this batch, they will check every second or every third product. Every second or every third product. So if there's like suppose 99.9% of the checked products are working fine, that most probably this batch is fine. This is how it works, right? Means most probably 500 phones will work fine. Similarly, they will check for this is the example of systematic. So instead of looking for each and every product individually, they will look for every second mobile or every third mobile and see the percentage of, like suppose they checked 10 mobiles here. Now from this 10 mobiles, all the 10 were working fine, or 8 were working fine, or 5 were working fine. So 50% was fine, 99 was fine, or 100% was fine. So if the percentage is good, like they are saying 99% of the phones are working fine, means out of 9, out of 10, 9 phones were working fine. So most probably the batch of 500 will also work fine. Getting the point? So here we can use systematic sampling when we need to check the condition, or we need to check any specific product in factories. So if it is clear, let us move to the next topic, which is central tendencies. Central tendencies. So suppose you have a data, okay, and you are plotting the histogram of the data. So this is your x-axis, and what is there in y-axis of this histogram? What is the y-axis of histogram? It's frequency or count. Okay. So if you forget what exactly histogram is, I'll give you. This is something what histogram looks like. Yes or no? So for this data, if I plotted this histogram and I smoothen out this histogram like this, I smoothen out, right? Now, central tendencies will help you to find where is the center of the distribution, at what value the center of the distribution lies. So there are three types of central tendencies: mean, median, and mode. So the distribution means the center is lying at mean, or the center is lying at median, or the center is lying at the mode value. That's what your central tendencies tells you. We have some distribution of data like this, right? So where is the center point of that distribution? Where is the center point of that distribution? Does it center point is at mean? That means the center of the data is the mean of the data, or the center of the data is actually the median of the data, or the center of data is at the mode of the data. That's what central tendencies tells you. So it is used to indicate where does middle or center of the distribution lies. Okay, so central tendencies have 3 points, like 3 categories. So I already told about that is your mean, median, and mode. Okay. So when we talk about mean, so let us talk about these terms one by one. What is the mean of the data? So it is the average of the data. So what is the formula of mean? Sum of observations divided by total number of observations, right? Right? So suppose if I give you a data of 7, 10, 15, 27, 38, 42, 96. Tell me what is the mean of this data. So basically summing up all the values like this, 7 plus 10 plus till 96 divided by total number is 1, 2, 3, 4, 5, 6, 7. So that is approx 33.57. So this was mean. Everyone is clear, right? Let's talk about median then. What is median? Median means the middle value, right? So suppose if I give you data like this, 20, 10, 40, 5, 4, 2, 3, 50. Tell me what is the median of this data. Okay, 1 second. I'll give you one more, that is 49. One more. In median, middle value after sorting the data. So sorting can be even in ascending or descending order. So if I sort this data, so first I'll get 2, 3, 4, 5. After 5, what we have? 10, 20, 30, 49, 50. And now you tell what is the median. 10. Now 10 is the middle value, not 4. Okay. And suppose the same data I am having without 49. Without 49. So if it is an odd number, then it's fine. We can easily find the median. If it is even, here it is even numbers. So that time we need to take the two most center elements and take the average of it. 5 plus 10 by 2, that is 15 by 2. So median will be here 7.5. Here everyone, this was the basic concept which you should remember. Now let us talk about mode. What is the meaning of mode? Most repetitive value. So suppose if I take the example, we have 2, 2, 3, 3, 3, 4, 4. Tell me what is the mode of this data? Mode is 3, right? But if my data is this one, 2, 2, 3, 3, 3, 4, 4, 2. Now what is the mode? Now you can see we have two elements. One is 2, which is repeated 3 times, and then 3, which is also repeated 3 times. It means maximum repetition is 3 here. So this time it is two modes we are having, that is 2 and 3. So if we want to use any one element, either we can use 2 here, either we can use 3 here. Clear? So don't get confused that if we have multiple modes, what to do in that case? Do we need to subtract this? Do we need to take the average or something? No average, nothing. These two elements will be your mode. Clear? If no repetitive, then no mode. So basically, if you got a data like this, so here maximum time repetition is basically 1 only, na? Because every element is repeated 1 time only. So all will be considered as the mode values. All the elements will be considered as mode. So this was the concept of mean, median, and mode. Okay, so let us jump to the next concept, which is of variation. What is the meaning of variation? Or we can call it as variance also. What is the meaning of variance? So variance actually tells you about the spread of the data, guys. Not only the spread of data from mean value. Okay. So like suppose you have two types of data in which the one points are like this and in other the points are like this. So can you tell me where is more variance and where is less variance? So we are basically calculating from the mean. So suppose this is the mean of this point and this is the mean of this data. So with the help of variance, we are trying to calculate the distance of each and every point from the value. Now let's discuss about the formula of variance. Standard variance formula. So no need to memorize the formula. It is even very easy. So guys, if you want to calculate the distance between any 2 points here, like suppose it is x1 and x2, how you calculate the distance between any 2 points? How you calculate the distance between any 2 points? Taking the difference x2 minus x1, that will give me the distance, right? Similarly, variance, we are calculating the distance of the points from the mean, right? So that means that x minus the mean of the data, right? Then we need to scale it. Why? Because we don't want any negative value, right? And this is for the 1 point, like x. But we have multiple points in the data, so we will do the summation and divided by the capital N. This is how standard variance formula looks like. So it was very easy, right? Okay. Then when we talk about standard deviation, it is nothing, just the under root value of standard variance. Okay. So next topic is to find the range. So tell me, what is the range of the data? It is the difference or distance between minimum and maximum value in the data. So the formula will be range is equals to max value of the data minus minimum. So suppose you have data points 7, 8, 2, 9, 10, 11. Tell me, what is the range of this data? What is the range of the data? So maximum value is 11 here, minimum value is 2 here, so we are getting the 9. So now let us discuss about one more topic, which is percentiles. So everyone please focus on this topic because it is something like sometimes it feels difficult to understand. So that topic name is percentiles. Okay, let us discuss about the topic of percentiles here. Now suppose you have some data. So suppose you have a data which stores the ages of person. So in your data, ages are stored something like this. 1 year age, 2, 4, 5, 7, 10, 12, 6, 5, and suppose 50. So what I can observe from this data is 99 percentage of data is less than or is of what we say small children. 99% data is of small children, whereas only one data point I'm having here, which is of old age person. That's what we can inference from here, right? This is how your percentile will help. Here, your 99 percentile value is equals to 50. What does this mean? That 99 percentage of data is less than number 50. So this 99 percentage of data will be less than number 50. Getting the point? So percentiles helps you to find a value below which certain percentage of observations lie. So if I'm talking about 99 percentile means 99 percentage of the data. If I'm talking about 50 percentile means 50 percentage of the data. If I'm talking about 75 percentile means 75 percentage of the data. Getting the point? Or let me explain you with one more example. So every one of you, I hope you know what is the marking system of competitive exams. IIT, JE, or IIT exams, CAT, GATE, any exam, guys, competitive exams. Do you know how the marking system of that is? They are not percentage based. That is percentile based, not percentage based, percentile. So let me explain you. So suppose you any topper in your class scored 80 marks out of 100. Okay, this is the marks of topper.
Now, in this, topper means rest of the complete class has marks less than 80. That's why we are saying the person is topper, right? So that means 100 percentile value here is equals to 80, means 100 percentage of other data points of other students have marks which is less than 80. Getting the point? So percentiles are the scores that are used to describe a value below which some percentage of observations fall. If this is clear, the next topic is very, very easy for you guys, which is quartiles. So, quartiles, I think I can relate this word to a quarter, English word quarter. And what does quarter means? 1 by 4. So that means I need to divide my data into 4 equal parts. So the first division will be made at the value of 25 percentile. The second division will be made at the value of 50th percentile, and the third division value will be made at 75 percentile. So, for example, if you have a data in which your minimum value is 1 and the maximum value is 100, and suppose here we are having 15, 45, and 80. Now, what does this means that at 25 percentile value is 15 means 25 percentage of the data is less than value 15. Similarly, 50 percentage of the data is less than value 45. Similarly, 75 percentage of data is less than value 80. Getting the point? So this 25 percentile is known as Q1, 50 percentile is known as Q2, and 75 percentile is known as Q3. That's just the notation what we give, right? Similarly, we have one more term which we use, which is IQR. So IQR full form is interquartile range. What is the value? It's nothing, just the difference of two variables, that is Q3 minus Q1. Like we have range, similarly we have IQR. So Q3 means the value of 25 percentile and Q1 means value of 25 percentile. What does this mean that in this data, what is your IQR? So at 75 means Q3 we have 80 and at Q1 we have 15. So 80 minus 15, which is 65. This is your IQR value, right? Then we will discuss about one topic which is outliers. So in machine learning, outliers topic is very important. Let us first understand the meaning of outliers. So I call this as odd one out values. Like suppose you have a data points like this. 1, 2, 3, 5, 7, 15, 20, 100. Can you tell me any value here which is odd one out value? 100, right? Because the other values range is very less, but 100 range is very high. So that odd one out value is your outlier. Similarly, if I take another set 0.02, 0.01, 1, 2, 3, 5, 7, 15, 20, 100. Now, can you tell me any value which is outlier here or odd one out? So, in right hand side, we have two values, 100 and 101, and in left hand side also we have two values. So, these values are your outliers. So, the extremist values on the right or the left side is known as the outlier, which is out of the range. So if your data is this now, like don't consider 100. If your data is only this, then you don't have any outlier, guys, because the range is quite okay here. The range is quite okay. But if the range of the data, like here you can see the range is 80, whereas here it is just 5. You can see the difference. Then only you will say it has outliers. It's not necessary that every data set will have outliers. Some have, some don't have. Clear? Now tell me which plot we use to find the outliers, which visualization plot we use to find the outliers. That do our data have outliers or not? Which visualization plot we use? box plot. So how that box plot looks like is, so if you have these black points like this, then we say that the data is outliers. Otherwise, the data don't have outliers. Similarly, yes, Boylan plot also. Boylan plot looks a leaf shape. So if that leaf is also having points, that means outliers. Otherwise, no. Right? What is the meaning of correlation? Correlation basically tells you the relationship of columns. Relationship of columns. Like if I'm increasing one column, what is the effect on the other column? Okay. So correlation is of three types. Correlation is of three types. What is that? Positive correlation, negative correlation, and zero correlation. Now, what does this mean that? So, guys, do you remember the concept of directly proportional and inversely proportional? What was directly that if I'm increasing one variable, the other variable will also increase with it. Like your supply and demand. If demand of any variable is increasing, the supply will also increase, right? Similarly, inversely proportional, if one is increasing, the other will decrease with it. Like if you will increase the speed of your vehicle, the time to get to your destination will decrease. That's what positive and negative correlation is. Positive means directly proportional, negative means inversely proportional, and zero means no effect. That if I'm increasing one variable or if I'm decreasing one variable, there is no effect on the variable. Now, which visualization tool we use for correlation? Which visualization tool we use? Heat map. So in ML, you are going to use this heat map a lot. So you will automatically remember this. Yeah. So this was all about your descriptive statistics from my end, okay, regarding your probability. So first tell me what is probability, guys? What idea you have about probability? Or we can also talk like what are the things, scenarios where you can say that probability will help me in data science. Why probability is important for data science? Probability basically helps the data scientist. Like if we do any kind of prediction or if we do any kind of statistical analysis, how probable that our analysis will be right or how probable it will be wrong. Like suppose I have forecasted that tomorrow it will be rain. Now, if I know the probability, how much probability my predictions will be correct, I can proceed. Like if it is still raining, my probability comes out to be 90%. Then if I'm working in some traffic agency department and there, I can help them to reduce the traffic. I can give them a prior idea that tomorrow I need more staff present. I need more traffic police as it is raining, so it could be more traffic there. So it gives you the likelihood or the probability that how much right your predictions will be. So probability helps data scientists and even data analysts to access the likelihood of events that in turns enhance efficiency of insights, like what insights we are basically making, drawn from statistical models. Now tell me what intro you know about probability. What exactly probability is? What is the meaning of probability? Definition. Try to recall. Yes, see. So probability is the way of measuring how likely something is to happen, right? And formula is like one of your student, one of your colleague has already given the formula. So the formula is probability is equals to favorable outcomes, favorable outcomes divided by total number. So let me also define about the outcomes. So what do you understand by favorable outcomes, guys? According to our needs. So the specific outcomes we are interested in. Like suppose if we toss a coin and I want what is the probability of coming head. So I want the probability of head, right? So head will be my favorable outcome. Means the outcomes which you are interested in. If you want to find what is the probability that tomorrow it will be raining, so yes will be your favorable outcome. So the specific outcomes you are interested in, right? Now then what are total outcomes? What are total outcomes? We have the formula as favorable outcomes divided by total number of outcomes. So tell me what are total outcomes? All the possibilities, all the possible outcomes. So let us discuss about some examples, simple examples. So first, flipping a coin, flipping a single coin, right? So what is the sample space you will get? Either you'll get head or you will get tail, right? So your favorable outcome, suppose we want to find what is the probability of head, right? Then we need to find what is the total outcomes here. Good, 2. So now, what will be the probability that it's a head? Put that into the formula. Yes, 1 by 2. So here it is basically 1 time head is coming. So 1 by 2, which is 0.5, is the probability that you will achieve a head, right? Similarly, if we flip 2 coins, so what is the sample space you're getting? So either I can get both head, either I can get one head, one tail, first tail, then head, or I can get both tails. This is the sample space, right? So favorable outcome here, suppose you want, what is the probability? I will get head and head. So how many times it's repeating? What is the total outcome? How many total outcomes you're having? 4. So the probability will be 1 by 4. So these are the very basic examples. I hope you have studied in your 6, 7 standards as well in your math session. Remember? So before moving ahead with further advanced topics, important terminologies we use. So I'll mention this topic as important terminologies. So the first what we are going to discuss is what do you understand by experiment? What is an experiment means? So an experiment is an event where uncertain outcomes are possible. This is how you can define this terminology of experiment. Then, what is event, guys? What is the meaning of event? The possible outcomes. Like if I'm having an event, I am doing this. I am flipping a coin. So my task is to flip the coin, right? That's what event is. Or we can also say that I'll send you another. So the definition directly from the Wikipedia is that the event means the set of outcomes of an experiment. For example, if I'm flipping a coin, so my sample space will be head or tail, right? What is the event that I'm getting a head or event of getting a tail? Okay, so you can even consider it as the subset of your sample space. So an event is a set of outcomes of an experiment. So let us discuss about sample space now. Tell me, what is sample space? All the possible. Sample space means, guys, all the possible outcomes. Like if I'm tossing a coin, what are all the possible outcomes? I can get a head, I can get a tail, right? So when I'm flipping only one coin, my sample space is only two, which is I can get head or I can get tail. Whereas if I'm flipping two coins, this will be my sample space. I can get both head, I can get first head, then tail, otherwise first tail, then head, and then both tail I can get. similarly, if we have a deck of cards, I hope everybody knows about those deck of cards game, right? So 52 cards, exactly. So if I'm taking any card from that deck of cards, so what will be the sample space? So all the 52 cards which I'm having in that deck will be in my sample space. So sample space basically means that all the possible outcomes. Sample space, total outcome basically means that we are counting that value. Like total outcomes here, we are having two. Here we are having four. If we are counting that total number of outcomes, that is total outcomes. If I'm just writing that this is the sample space here, if I'm mentioning those outcomes, like what are all the possible outcomes, that is your sample space. Okay, let me talk about next more three. They are also important. What do you understand by equally likely events, guys? Equally likely events. What is the meaning of equally likely events? Equally likely, guys, from the name itself, try to understand. Like, equal matlab, likely means probability. Events means the event what we are having. Don't you think so? Events which have the equal probability. From the name itself, we can define the definition, right? Events that have equal probability. For example, your coin, the probability of head and the probability of tail is equal, that is 1 by 2. Or when you have a dice, so the probability of any number here is equals to 1 by 6, means every outcome is having equal number of probability. That events are known as equally likely events. So let me write the definition. Events that have the same chances or probability of occurring. But here is one note point, guys. What is that note? That the events or the outcomes should be independent of each other. They should not depend upon each other. So if I am tossing a coin, my head and tails are not dependent, right? Like if first time I'll get head, second time it's necessary I will get tail or something. No, they are independent of each other. So that is very much necessary. The outcome of one event should be independent of other. I hope it is clear. The next one, mutually exclusive events. Mutually exclusive events. Try to think. So, mutually exclusive, exclusive means don't include anything, right? Now, events that cannot happen simultaneously, right? That's a mutually exclusive event. Like, again, flipping a coin, I cannot get head and tail both together, right? We cannot get it. Either from dice also, I cannot get two numbers same time. So events that cannot happen simultaneously, right? Another example of weather or climate. Climate can be either hot or cold. At one time, it will be either hot or it will be either cold. Coin example, dice example, true false example, or any 1 0 example as well. Clear? Then similarly, we have one more which is mutually inclusive. Now tell me what could be this mutually inclusive? Events can occur simultaneously. Any example? Okay, I'll give you one example, then you think of any other. So if I'm taking a card from the deck of cards, so I want to find what is the probability that the card is of diamond, the card is of diamond and a number 4. So here we are having two events together. One is card is red and number is, or we can say card is red of number 4. Holiday and Sunday. Like, what is the probability that it will be a Sunday and also a national holiday? So, so these are the few examples of mutually exclusive and mutually inclusive events. Before moving ahead, let's discuss about types of probability. So, probability can be broadly classified into three types. The first type is known as marginal. The second type is known as joint. And the third type is known as conditional. So probability is broadly classified into these three types. So have you heard about these types before? So let us discuss with a very, very beautiful example. That example is actually I've taken so that you can understand about these three individually and also the differences between these three. So using one example only, we will try to distinguish between these three types. So let me build the example first. So a survey was conducted with 500 strangers. Okay, there was a survey regarding games, that which game is played by the person. And the results comes out to be like this. So the games, like they ask that male, female, total. So how many of them plays football or rugby or any other game? Okay, a survey was conducted. So total we are having 500 persons. So from all the 500 persons, there were 270 males and 230 females. And the total who plays rugby was 195. Sorry, football was 195, and for rugby was 125, and other was 180. Then, from all the persons who plays football and also who is male, means how many males were playing football? That is 120. How many females were playing football? That was 75. Then how many males were playing rugby? That was 100. And how many females were playing rugby? That was 25. And how many males play other sports? That was 50. And how many females play? That is 130. Let me know if this picture is clear, like how it came. So this was the number, but if I want to get the probability, so I'll mention here, to get the proper probabilities, divide each by total number of persons, that is 500. So we are going to divide male, male, total, football, rugby, others. So kindly divide each and every value by 500 and tell me what will be the output. So I'm giving you time of 2 minutes. You make a note at your end where you will divide each and every element by 500. 120 by 500, 75 by 500, 195 by 500. So after 2 minutes, I will start what answers you're getting. Clear? Keep a note at your end and divide each and everything with 500. What is 120 by 500? 0.25 or 0.24? It's 0.24, not 25. 0.24. 75 divided by 500? Good. 0.15. Now 195 divided by 500? 0.39. Similarly, 100 by 500, 0.2. 25 by 500 will be 0.05. 125 by 500 will be 0.25. Then 0.1, 0.26, 0.36. Then 0.54, 0.46, and right. So we have find the probabilities. Now let us discuss that what is marginal, joint, and conditional probability. So first I will talk about the joint probability. Joint probability. That was just an example. Through this example, we will understand about the probabilities. Okay. Right now, we were just discussing about one example. I have built the plot now. Now I will use this example to explain you about the probabilities. Now, joint, guys, from the name itself, it is clear that we are joining two events. That means, don't you think so? It is kind of mutually inclusive events. Means the probability of the events occurring together. So in our case, don't you think so? If we want to find the probability that the person is a male and play rugby, that is this probability is 0.2. Similarly, person is a female and plays rugby, that is 0.05. So these two probabilities are your joint probability. What does this mean? That it is used to calculate the probability. It is used to calculate the probability of two events occurring together at the same time. So it is denoted by P, A, and B, or probability of A, comma B. It can be more than two also, Mohammed. Depends upon the example or depends upon the condition. So in our example, so in our example, joint probability of someone being a male and liking football, right? Or all the values which are here, 1, 2, 3, 4. Don't you think so? These probabilities are joint probabilities. All the six highlighted probabilities are the example of joint probability. Joint probability means the probability of two events occurring together. So in this all probabilities, we have two events. What one is the gender event, other is the game event. So here means that I am finding the probability the person is a male and playing football, right? Similarly, here the example is person is a female and playing football. So two events we are having. One is it's a football and the gender is female. Similarly, here we can say that the person is a male and play rugby, whereas here the person is a female and plays rugby. Clear? But there is one note point, guys. We have one note point. What is that note is? Joint probability is symmetrical. Now, what do you mean by symmetrical here? What do you mean by symmetrical? Means if I'm finding the probability of A and B, it should equals to probability of B and A. Like if I'm finding what is the probability the person is a male and play rugby, should be equals to what is the probability the person first plays rugby and then it is a male. So both of the cases it should be equal. So that's what joint probability should be symmetrical. What will be marginal? Try to think. Try to think, guys, what will be marginal? So if joint means two events together, don't you think so? Marginal means a single event we are talking about. So in our example, we are basically talking about the person is either male or female, or either the person is playing a particular game. So marginal probability, it is the probability of an event irrespective of the outcome of another variable. So it is denoted by probability of B we are talking about. So like this was our example. So here like if we see that so from all the 500 people, I want to find the probability. that the person was male. We don't care what game he prefer. We only prefer that the person was a male. So this probability. Similarly, 0.46 that the person is a female. Or 500 people, I want the people who plays football, irrespective of what gender they are. 0.39, 0.25, and 0. So don't you think so? These are the examples of marginal probabilities. In these examples, we are talking about the person is either male or female. We don't care what game they are playing. We only care from 500 people what is the probability the person was a male or the person was a female. I don't care about the game. Similarly, these probabilities were games irrespective of the gender. I want the probability of people who plays football irrespective of they are males or females. So individual probabilities is known as marginal probability. Individual means that we are concerning only about one event. Here we have two events now. One is gender, other is game. So either we are focusing only upon the gender, the person is male or female, irrespective of the game, or we are only considered about the game irrespective of gender. So either we will consider game or either we will consider gender. Then there's another which is conditional probability. Conditional probability. Now, conditional probability means that it defines the probability of one event occurring given that another event has occurred. That means one event already occurred. We want to find the probability of next event which is dependent upon the previous event. So the formula of conditional probability is probability of A comma B divided by probability of B. So here we are finding probability of A given B. Now, if we talk about examples, now suppose in our example only, it is given that the person we selected is a female. So, for example, probability of preferring a sport given the observant is female. Now, one event already given that the person is female, and we want to find the probability of preferring a sport, suppose rugby, right? So, probability of we need to find the rugby given that it's a female. So, that will be probability of like according to the formula A comma B means probability of female plays rugby divided by probability that it is a female. So probability of female plays rugby. What is the probability? Tell me. It's a female and plays rugby. What is the probability, guys? 0.05 divided by it's a probability that it's a female. What is the probability that it's a female? 0.46. So this is how we calculate our conditional probability. Let's talk about one more that is Bayes theorem. Bayes theorem is actually nothing, guys. It's the extension of conditional probability. Mathematical extension of conditional probability. So the formula of Bayes theorem is probability of B by A into probability of A divided by the same statement again, probability of B by A, comma, probability of A plus probability of B when A did not occur, multiply by probability of A. It is nothing, just the extension of your conditional probability, the mathematical extension. So derivation and all that stuff will not be important, guys, for the Bayes theorem. Okay. So this was all about your probability. So if no doubts, let's discuss about the probability distribution. Okay, probability distribution, guys, it's very, very easy to understand. Suppose you throw 100 dice, we throw a dice 100 times, right? Now I will record that how many times I'll get one, how many times I'll get two, how many times I'll get other outcomes. Okay, I'll record that. One, two, three, four, five, six. Now suppose you got one five times, you got two, suppose 10 times, you got three, suppose more number of times, 25 times, or you got four, then you got five, then you got six. You have just count the frequency, right? Now, when I am smoothing out this graph like this, when I'm smoothing out this histogram like this smoothing part is your probability distribution. Clear? The smoothing part of this is known as probability distribution. So it is basically finding the probability of different possible values of a variable. So here my possible values was 1, 2, 3, 4, 5, 6. So it is telling me what is the probability. So here I can see that the probability of coming 3 is the highest and probability of coming 1 and 6 is the lowest. So that's what probability distribution helps you. Clear the normal meaning of probability distribution? Yes or no? Now there are two types of probability distribution, guys. Means two types of data we are having. So because we have two types of data, we have two types of probability distribution. So I hope everybody knows what is that two type of data, discrete and continuous. You know what is the meaning of discrete and what is the meaning of continuous? Yes. So means that for discrete data, we will be using discrete probability distribution, and for continuous data, we will be using continuous probability distribution, right? So I will write here used for discrete value, used for continuous values, right? So can anybody give me the examples of discrete data? Example of discrete data. So number of students, not marks, number of students in a class, because students can be either 30 or 31. We cannot say we have 30.5 students, right? Number of students. Or we can say coin example, head or tail, or we can say dice example. We can get 1, 2, 3, 4, 5, 6. We cannot get 1.1, 2.1 like that, right? Then what will be the example of continuous? What will be the example of continuous values? Heartbeat, good, very nice. Weight or height of a student, loan amount, temperature, very nice. Loan. These are the examples of continuous value. Now, guys, I'll tell you one important thing. In reality, now, we will get this histogram. You can see we will get this histogram. To achieve this curve, we use a function of probability distribution. We use a function. Okay. So when we have a discrete data, the function name is PMF, which is probability mass function. Using this function, we will plot the discrete probability distributions, right? Similarly, when we have the continuous data, the function we will use is PDF. The full form is probability density function. So using these functions, we will plot the probability distribution curve. Now we will study about different types of probability distribution, guys, we are having. So in discrete, we have binomial probability distribution, Bernoulli's, and Poisson's. Whereas in continuous, we have normal distribution. So we will discuss about these distributions one by one. So this was the flow chart of probability distributions. First, let us discuss about Bernoulli's distribution. It's very, very easy. Bernoulli's distribution means when whenever our outcome is binary, guys. Outcome is outcome of an event is binary, like real time where we can use it. Like suppose I want to find the probability that tomorrow it will be raining or not, one or zero, head or tail. Whenever we are having only two outcomes, we will be using the Bernoulli's distribution. What is the probability that you will pass in tomorrow's exam, right? But only one thing you need to note here. What you need to note here is number of trials. Suppose if I am tossing a coin and I want to find the probability of head or tail, so two events I'm having means two outcomes I'm having, that means I'll use Bernoulli's there. But number of trials will be one. Means only one time I can toss the coin. Only one time I can find it. So for this, the function is PMF. Remember, I told you about that we will use the function as PMF. So let me give you the formula of PMF, but you don't need to remember it. So don't worry. It is just a mathematical formula. You don't need to remember these formulas. So it will be either the probability will be yes or the probability will be no, where x is equals to number of trials. So the formula exactly is, don't go with the formulas. Probability mass function. This is the PMF function. Here, when we comes to real cases, do we need to find anything only one time? Means number of trials should be one. Yes or no? No, right? That's why we have the extension of this Bernoulli. We have the extension that is binomial distribution. Extension of Bernoulli's. P means probability. Here also we are having two independent outcomes like where head and tail, true, false, yes, no kind of situations. But only the difference is here number of trials will be infinite or multiple. So the formula here is, again I'm saying, no, you do not need to learn the formula. Only it is for the developers who actually creates these formulas. But a basic understanding that is required. N is equals to number of trials, X is equals to number of successes, and Q is equals to probability of 1 minus P. So difference between Bernoulli's and binomial is only one, that is number of trials. Clear? Bernoulli means one trial, binomial means multiple trials. That's it. So do not read to remember the formulas. Clear? Then let's discuss about the Poisson's distribution. Now think of a situation, guys, that you are manager of the server team in your company. Okay. Now it's a company of a call center where you get several calls, right? Now, everyone knows that if we will get calls, there will be a burden on the server if the calls are very huge, right? Now, if you are a manager of that, you should be aware about, right? What is the times when I get the highest calls in my customer care so that I can increase the load or I can uh, increase the capacity of the servers, right? Whereas, what is the time zone when I get very less calls so that I can leave the server as it is. Because the thing is, suppose the load of the server is less and you got multiple calls at that time. Your server will be overloaded and maybe it will crash also. That time we use this Poisson's distribution when we need to find the probability of a certain duration. Let's take another example. Suppose this Saturday, Sunday, you sold this many books. You want to find the probability that what will be the sales in next Saturdays and Sundays. Or you can say the arrival of emails. Getting it? So wherever you want to find the probability between a specific time duration, you will use Poisson's distribution there. A discrete distribution estimates the likelihood of an event in a given time duration. So here formula is lambda x divided by x factorial e minus lambda. So x means number of successes, lambda means mean number of successes, e means a constant value. So these were the three discrete probability distributions. So the last distribution is normal distribution, which is very, very important, like very, very important comparative to your other distributions also. And also very, 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 very easy. Now see, then I will plot the distribution curve. It could come to any shape, right? The shape could be like this, or the shape could be like this, or anything else, right? But when the shape of your distribution is like this shape is known as bell curve. So if the shape of your distribution is like a bell curve, it's looking like a bell here, right? It's looking like a bell. So if the shape of the distribution is like a bell, we call it as normal distribution. So when distribution follows a bell curve, we call it as normal distribution. Only the shape, guys. Now, why this shape is so important, right? Why, if I have this specific shape, we have a type of distribution. There is some special things about this. What? The first property it has is this shape, the mean, median, and mode values will be equals to each other. Means whenever we have this shape, my three M's of statistics values will be same. The second property is it is symmetrical. It is symmetrical. Symmetrical means mirror image. Left hand side will be equals to right hand side. And the third property is a special case. Special case of this normal distribution, which is known as standard normal distribution. Now, what is the special case? So I know that in normal distribution, my values of mean, median, mode will be equal. But that could be equals to anything. That could be equals to 6, that could be equals to 10, that could be equals to 100, anything. But in standard normal distribution, that value will be always equals to 0. Means at origin. What does this mean? That if I'm talking about the normal distribution, that could be anywhere in the graph. But if I'm talking about standard normal distribution, that will only lie at the origin value. And one more, standard deviation value will be equals to 1. That's what about your normal distribution is. The function here is fx is equals to 1 by sigma under root 2 pi exponential of minus 1 by 2 x minus mu by sigma the square. This is the function. Where sigma is standard deviation, mu means mean. Now there's one last concept which is similar to this, normal distribution, which is central limit theorem. Anybody knows what is central limit theorem? It is related to this normal distribution only. Anybody knows what is it? It says that it's a like proven experimental technique, guys. It's not like we can see examples or we can see something like that. No, it is just an experimental value or experimental theorem which scientists discover. What they discovered is like whatever the shape of the population is, the population could be of any shape. That could be this shape, that could be this shape, that could be any shape of the distribution. Central limit says that if I am taking a sample from this population and that size is greater than 30, it will, that sample will most probably follows a normal distribution. Means here sample population or sample distribution will not depend upon population. Whatever the shape of the population is, if I'm taking a sample greater than 30, it tries to or it tends to be a normal distribution. So let me define it properly so that you can even answer it. It's an important interview question as well. So you can easily answer it. It states that if we take several random samples from a population that has a finite variance, the mean of the samples tends to follow. Clear? So here your sample size should be greater than 30. That's what your central limit theorem is.
So I'm importing the necessary libraries first. Now keep the name of the data as data. Okay, so let it keep as df pd dot read underscore csv, in which I am loading it country profile variables dot csv and df dot head. What is the shape of the guys? Complete shape of the file. So the command which we can use is df dot shape here. So this will give me the shape of the data, which is 229 and 50. So 229 rows you're having and 50 columns you're having, right? So you can see here like how many columns, 50 columns we are having, right? So df dot columns, we are having 50 columns here. So this data set, I think everyone can understood that this is regarding the variables of the country. What is the name of the country? What is the region in which the country is? Surface area of the country, population in thousand, population density, sex ratio, and so on. We have these parameters. So if you from the geographic background, you are well aware about these parameters. Yes or no? Otherwise, you can just understand it as the variables related to your country. So, from this data, we need to just apply the descriptive statistics concepts. So, before that, few commands which are very, very important for you. So, the first command is how to check the null values in your data. How to check the null values in the data. So write the name of the data frame, dot is null command. Okay, this command will give you the null values. But the thing is, there is one problem with this command. What is that? It will give me the output in the Boolean format. So you can see that wherever you will be having a null value, it will give you true, otherwise it will give you false, right? But the thing is, it is difficult for you to manually see each and every value wherever I'm having true, right? So what we use is dot sum here. What this dot sum will do is basically count the number of null values. So right now you can see that in every column it is 0, that means that you don't have null values in your data. So again, if I use total sum, it will give me the total number of null values in the data, which is 0 in our case, because we don't have null. In case we have null values, it will give me the count of that null value. Okay, now tell me, what if we have null values? Rajesh, first sum will give me the null values in every column, you can see here, and second value is actually counting these all numbers present here, the total count it is given. Okay, now the thing is, guys, what if we have, right now we don't have, but what if we have null values? What to do in that case? What if we have null values? So there are two methods we can do it. One is drop the null values. So if the null values are very less, we can drop it. Otherwise, we can fill the null values. Now we will fill the null values with what? We use the fill now command to fill those values, but with what we fill it? With what we fill the null values? Single sum is giving you the number of null values in each column separately, and double sum is basically giving you the total count in the data frame. So it depends upon you. If you want to see in every column what are the null values, you can use single sum. And if you want to use the total null values in my data frame, I use the doubles. So I'll give you a separate command for it then, if you're getting confused here. So single sum is giving you the null values in each and every column, and the double sum will give you the count. So I'll separated the command so that you can easily relate. So we will fill the null values, guys, most probably with mean or median, or if it's an object data, we will fill it with O. And sometimes we fill it with 0 also. Now, how to check for duplicates? Do we have duplicate data or not? How we check that? What is the command? It's df dot duplicated, guys. It's not duplicate, it is duplicated, not duplicates also. See, if I'm writing here duplicates, it will show me an error, or if I write only duplicate, again it will show me error. So the command is duplicated. But again, the same problem we are having, it will give me in Boolean format. So what we will use? Dot sum. So it will count the duplicate values. So right now we have 0 duplicate values. Now let us start our descriptive stats. So for this, randomly you can pick any column, guys. I am taking this population in thousands column. Okay, so we will do our descriptive stats based on this column here. You can pick any column as you want. Okay, but for this session, I also first do with what I am doing, and for the practice, you can take any other column. So for our analysis, we have chosen this population in thousands column. So first we will find the mean. So first, what is the basic formula of mean, guys? Like first, let us do it manually, and then we will use Python function. So what is the formula of mean? Sum of observations divided by total number of observations, right? Now let us do how we can do, if we don't know what is the function and all, how we can do it manually. So sum of observations means I need to take the sum of this column population in thousands. So I'll copy the name from here. So it's better to copy the name instead of writing it, because in writing we can miss some spaces and all, which will cause me errors. So how to get the sum, guys? I think you should know the command. Which function will help me first to get the sum? I think dot sum. Yes or no? Dot sum. Now I can print sum of observations is sum. So sum of observations we got is this. Now we need to find the total. So I'm choosing a variable. Again, I'm choosing this column. How to find what is the total number of observations here? So either you can use, guys, dot count function. Dot count function, it will count the number of observations, or you can even use the length function. length will also give you the same answer. Both you can do, right? So we got sum, we got total. Now we can easily find mean is equals to sum divided by total. Let's see what is the answer. So it's 32756. So now similarly, guys, manually try to do median and mode also. How manually we can find median and how manually we can find mode. So first we will find the length of your column. Okay, so basically at first we need to find, is it a even length or an odd length? So we can see here it is odd length. So basically if I divide here by 2, it will give me the index value of the, what we say, the middle element, right? Now I can easily from you, I can find the element at this index. So I take the column name, but first we need to sort the values also. Sort underscore values, because after sorting only we need to do, right? And here I can find the index of 114. That is 2233. But there is one more thing, guys. There is one more thing you need to understand is what? When we sorted the values, so if I sort here, when we sorted the values, the index values are also changed based on what sorting is done. So that means you also need to do reset index, or we can say ignore index. Ignore index is equals to true. What this will do is it will basically give you the index values from 0, 1, 2 instead of the shuffling one. Clear, everyone? And now I can find what is at 114 index. So 5448 is your median. Clear, everyone? How we found the median? Then how to find mode? Mode is, I think, very, very simple. Just value counts, right? Dot value counts. It will give me, so the highest time repetitive is 28905511. So I can see here multiple modes I am having. So remember, we discussed the example in theory also that we can have multiple modes. So here you can see here that we do have multiple modes. Now this is how we have done it manually, right? But do we have functions for it? Yes, we have. What is that functions? So in real life, we don't do manually, we use functions. So we have, for mean, we have dot mean function. So I'll print this. Mean is similarly for median and for mode. For median and for mode, we have these functions. Clear, everyone? So you can see here you are getting multiple modes here. Why? Because we have multiple values which is repeated equal number of times, like the example we discussed in theory. So that's why you have multiple modes here. Clear, everyone? So in real, we can use these functions to find mean, median and mode. So see the difference in the output. You have the index values jumbled up here, right? And in ignore index, you don't have the jumbled up values. Okay, so we have found the mean, median, mode. Then we will find the variance and standard deviation. For variance, the function is dot var. Okay, and for standard deviation, the function name is, it is std. Run this and you can see variance of your data is and standard deviation of your data is this, right? Now tell me, relationship of, this is a very good interview question also. What is the relationship between variance and standard deviation? What is the relationship between variance and standard deviation? As we have studied this, your standard deviation is equals to square root of standard variance. That was the relationship. Now, can we cross check it? That is it really true? That means this value should be the square root of this value. So let us check how we can do it. First, import math, in which std is equals to math dot square root, or the function name. We can write sqrt also. Yes, just a minute. We can write sqrt, in which I will pass the variable name. So let me store it into a variable. So I'll take this value and store it into, or we can directly pass also instead of storing. And st, let it run. So don't you think so? You are getting the exact value. So it is now proven that your standard deviation is actually the square root of variance only. So the thing which we have studied in theory, we have proved it here. Similarly, how to find the range? We have studied about range also. What is the formula to find the range? Maximum minus minimum, right? So how we can find the maximum? Which function we have for maximum? Dot max, right? Similarly, for minimum, we have the function dot min, right? And we can print maximum value is max variable, and print minimum value is min variable. So this is your maximum, this is your minimum, and we can easily find the range now. Range is equals to max minus min, and print range of the data is the range variable. So this is how you can calculate the range also. Clear? So you can see how these concepts are very easy to implement, right? So we found mean, median, mode. We found range. We found variance, standard deviation. We are left with percentiles, quartiles, and correlation. These three topics is what we left. So let's talk about percentiles. So everyone remembers the concept of percentiles? Let me relate to that example. Now suppose you have one student in the class who scored 75 marks out of 100. Okay, and this 75 value is at 60th percentile. What does this means? That 60 percentage of other students in the class have less marks than 75. So percentiles are the observations. They will give you a value below which some percentage of other values belong. Clear? So how we can find it using Python? Let's see. So suppose if we want to find 75 percentile, we will use the function np.percentile, in which I will pass the column name and comma which percentile I want. So suppose I want to check what will be 75 percentile value. So print this. NumPy is not defined. I think we have run the code for NumPy. Okay, we have not run this as NP. So you can see that at 75 percentile value is 19193, which basically means that 75 percentage of other values is less than this value. Clear? Similarly, you can find 25 and you can find 15 also. So give me what is the value of 25 percentile. What value you will get for 25 percentile? So I'll copy the same code. Here I will change the variable name and I'll give it 25. And so yes, 431. Similarly, we can find the quartiles also. So what was quartiles? Remember Q1, Q2, Q3. Q1 means 25 percentile. Q2 means 50 and Q3 means 75, right? So either we can find the percentile also, like here this 25 percentile is basically my Q1. So like this also we can find, but we can use another function also. What is that? I'll take the column name dot quantile function, in which I will pass 0.25. So that is 431. You can see exact value you got. So you can write here Q1 is equals to print Q1. So either you can find through percentiles also, or you can find it to quartiles also. So tell me what value you will get for Q2 and Q3. Let's see for Q2 and Q3, what value you will get. Q2 means 50 percentile. So this is giving you the value below which all other values, all the 100% of values belong. That is means we are finding the maximum value, and you can see here the maximum value is also same. So yes, Q2 and Q3 value also we got perfectly fine. See how easy it is to implement in Python, right? And the last concept we are here with correlation. So remember how many types of correlation we were having? We discussed positive, like we discussed in the starting, positive, negative, and zero. So how we find it? Function name is dot core. So DF, you can see you're getting the correlation values of each and every column here, right? And also we can plot, which visualization plot we use. We have discussed, guys, like that time you were not aware about that plot. So let me discuss that plot with you. Which plot I told you guys we use for correlation? Heat map. And how we can get that heat map? SNS dot heat map. Here we will find df dot core. Run this. See, you're getting the proper heat map. Now how to interpret the values? You can write here and not is equals to true. So you can see values are also visible, but values are overlapped here, right? So I will increase the figure size. So plt dot figure. Inside that we will increase the figure size is equals to, I think 15 comma 10 will work fine for my system. So yes, you can see the values here. Clear everyone? So you can see here some negative values and you can see some positive values. So negative means they are negatively correlated and positive means they are positively correlated. Clear everyone? So this is how we find the correlation.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
So first thing first, what is the difference between statistic and statistics? So descriptive is done. So what is the difference between statistic and statistics? Statistic versus statistics. This is the first question I asked when I talk about statistics. If you observe, there's just one extra letter S in there, right? That's the difference in the spelling, not in the concept. Statistic can be a single piece of data. Okay. So this is a question out of syllabus, right? You might say you have done this statistics, and so I think this is a more like a teacher's way of testing where the unexpected question might come. So see, statistic, you're close. Statistic talks about statistical technique. Statistical technique like, Z-test, T-test, chi-square test, right? All these are your statistic. More like it's an approach, it's a method within the universe of what? Statistics. Statistic is a subject, right? So statistic is more like a method or approach or technique which you apply on a set of data which you have collected over a period of time. You have done some transformation. You are going to analyze with the help of these tests. Okay. So statistics, you already know it's a subject, quite an interesting subject. How was your introduction to statistics? Like, did you feel that statistics can be a really interesting, topic or interesting area where you can learn? How many of you guys felt that oh, statistics something I should, pick it up? Studied statistics till the descriptive was taught to you, right? I know some of the students are there. Okay, reasonable, quite interesting. So let me couple of things and let's see, understand you few things that what is your understanding of descriptive statistics a little bit more so that I can use some of those things in inferential. So I'm just making sure. So tell me one thing, if I talk about salary, right? And I have a very good diagram for that. So you must have, this is the time, by the way, guys. So those who have been to uh, engineering colleges or typically I would say IITs, December is day one. December 1 is day zero for them. So this is the moment I am sure my juniors will be getting placed, right? So this is a bell curve which I put together, and you might be seeing something coming in the news, right? 1 crore package. Let me tell you, I have been asked this question a lot of time. 1 crore package is a myth, or more like it's a misinformation given to news media print to get some footage or mileage. Definitely, some of the guys, maybe one or two or three people in a batch, they get 1 crore, but that's all in dollar. Means it's not in India, it's in US or likes of US. So converting dollar into rupees and then telling you are getting a package of 1 crore, the people forget that they have to spend in dollar. They'll not take a flight, come back to India and spend in rupees. Understand my point? So 1 crore package is okay, right? It's not like in India, hardly anybody gets as a fresher 1 crore package. If some company is giving, they're idiots. The company owners or the board is idiot. Okay, doesn't make sense. So definitely you can see this is a skewed distribution. And as you can also see, I've already written it's a right skewed. Anybody? Why it is called right skewed? Why is it called so? Because it has a long tail on the right side. Some of the guys will be wondering what is that long tail. Let me highlight, you will see it. Can you see the distribution is going like this, has a long tail. This is what we say long tail. And the peak is on the left hand side. So it's a right skewed. Okay. Now you must have been taught when the data is symmetric, when the data is uh, having a shape like this, the distribution. So then mean, median, mode, all are going to be at the same place. Remember? Now, when the data is skewed, then there is an issue doing mean here. Okay. So far with me, guys, doing mean here. And what is the reason for that? Because mean is sensitive to outliers. I hope must have been taught this, right? Mean is sensitive to outlier. And this is a very, very common concept. Are you guys aware? Mean is sensitive to outliers. Let me show you if you're not. Tell me one thing. I've also written some packages. Okay. Let's say this is not 51, by the way. This is 5 LPA. Let me write clearly. Else you'll start laughing at me. 5 LPA. Let's say most of the guys are getting 5 LPA. That becomes, if you think this is your, this is the peak of the salary, you can say like a mode. So this is the highest value which you see in the normal distribution. So that's your highest frequency value, which means it's the mode, right? Or you can say close to median, but it cannot be the average. You know why? Because of these guys who are sitting somewhere here. Can you see this? Who are sitting here? They are going to impact the average. Let me give a simple example. So let's say these are your salaries, 3, 5. I'm taking some numbers in LPA, lakhs per annum, 50 and 80, let's say. So let's say these guys' salary, if you want to find, and this is all in LPA. So if you do the math, what is the mean salary? If someone can do this for me, you will get to how much? And I think I have 3, 6, 9, 10. So what is it coming, guys? Did someone do? 81.5. No. How can be 81.5 average? Only two values are 50, 80. 18.2, so many people are telling. So let's say that's the average. Okay. Right. But if you observe closely, most of your data distribution is not even higher than 10. Right, guys? Can you see this? Just because of these two guys who are like the IITs, that media guy who are getting this high package has impacted your overall salary. Why don't you do that? If you exclude these outliers and do this maths again, add these 8 salary only and divide by 10. Oh, sorry, divide by 8. How much you are getting, guys? I think it will be close to 6 or 7, 6.5. Okay, thank you. Those who are helping me. Do you think which one looks more closer to reality? This one or this one as an average salary? Definitely 6.5, right? Definitely 6.5. So you understand when I say mean is sensitive to outliers. And that's the reason people say whenever you are looking at a data with outliers, you should not go with mean, you should go with median. Now, why don't we find median for this one? So just arrange 3, 4, 3, 4, 5, 6, 8, 10, 11, 50, 80, 2, 4, 6, 8. I missed one number. I think 5 is 2 times, right, guys? Okay. Now tell me, guys, what is the median? So I'll come to you, Aryan. 2, 4, 5, right? So what you will do, my dear, you will take first 4 and second 4, last 4. So you will be left out with what? What is the average? I'm damn sure you must have been taught how to calculate median. So what is the average of these two? I'm not going to teach that. I'm just making a. Now tell me, looking at this number and this number, which one is more realistic? Mean is more realistic or median is more realistic to the average which you might have thought. So now you understand. So that's why if you see, if some apps like Glassdoor or some similar like PayScale, if they report average salary, you should not never go with that. Because let me also tell you, there are students who are coming from ISB and all, and they're getting 30 lakhs as a fresher salary. And then there will be students who are coming from normal college, they will be getting 3 lakhs or 5 lakhs. So 30 lakhs guys, if you keep taking right blindly, you will be in a wrong, means you will in a bubble that thinking, oh, I am also going to get 30 lakhs. So just to just to bust this thought that it doesn't work like this. Okay. So does it make sense, guys? Now coming back to Aryan, outlier. Identifying outlier, treating outlier. Okay. So remember I had taught you guys box plot. Okay. So box plot says that if something is in, I'm just more like, revisiting few things. So Aryan, if you do a little maths and try to identify an outlier, you will be able to do that. So now my question is, did you guys go through some of those examples where you identify the outlier and treat the outlier already, right? So generally, there are 2 on the upper side and 2 on the lower side. We have outliers. Okay. So there is a statistical way to calculate these whiskers known as whisker. I have also talked about it in my visualization. Let's say this is your upper threshold. So guys, I'll not repeat it. I'll quickly write the equation. You take the Q3 and then you add the 1.5 times. Statistically, this number has been given to you, this whole formula. You do the interquartile range, which is Q3 minus Q1 and multiply with 1.5. Anything which is greater than this, like these two guys, are going to be outlier. Similarly, you can also do lower threshold. Just refresh your memory. So that will be Q1 minus 1.5 IQR. IQR is interquartile range. Anything lower than this lower threshold, like these guys, are outliers. And you can also make a little sense out of it. If someone is getting outlier means little something unexpected or weird, right? Everybody is getting 5 lakhs, 6 lakhs, 10 lakhs, and somebody is getting 80 lakhs. Definitely that is an outlier. That's a normal way of saying it. So outlier means which is not normal, which doesn't fit in normal scenario, is an outlier. Literally, I'm trying to explain. Mathematically, this is how do you do that. Okay. Now, guys, I'll jump one question. And if you have been taught normal distribution, you should be able to take it because then you must have been taught Z score as well, guys. Z score was taught to you guys? No? So then what did you guys do in normal distribution? There's no normal distribution without Z score. And without the normal distribution Z score, I cannot go into inferential. So it's a prerequisite. Min and max is nothing. Maximum value in the data is maximum, minimum is minimum. Okay, simple. Why the outliers are not considered as what? They are, see, this minimum, na? This minimum is like for they're actually taking at lower threshold and upper threshold. Okay, so don't get confused. This is not our minimum maximum. Obviously, minimum of the data will be the outliers, right? If they are lower the threshold values, right? Lower than the low threshold. You have a good point, but they were talking about this whisker, okay? So remember, there's a bell curve, okay? Standard normal distribution. Let me do the thing. Okay. So one of the key distribution is normal distribution, also known as bell curve. Bell's curve. It has gotten a name, bell curve. Anybody knows why it is? Because if you go to a temple, right, and have you seen a bell, right? The normal distribution can be, shown as a bell curve. Okay, and here you go. Now, if you look at the normal distribution, okay, most of the thing in the world can be modeled as a bell curve. Trust me on that. So that's what I was telling, right? If the normal distribution is symmetric, your mean, median, mode all will be on the same point. Okay. So ideally, when we talk about standard normal distribution, you make sure that it is symmetric, it's not skewed. Okay. And if you look at the top one, not the bottom one, the top one, you must be seeing that I have given three colors. One is, between mu plus minus sigma. So I hope you know what is mu, what is sigma. So this is going to cover how much of your data? 68.27%, right? And then if you look at the from mu plus minus 2 sigma, 95% of the data will lie in there. And if you go and stretch it further, mu plus minus 3 sigma, 99% of the data will be there. So you might be wondering, why do we need normal distribution, right? And why mu plus minus sigma is so important. See, this is what has been found or observed on a normal distribution because it's all about probabilities of what data will lie in where. So if you take any normal distribution curve, you can always find mu, which is your more like expectation of x. Don't go into this. It's a random variable. I'm damn sure you don't know. So expectation of x is generally written as mu, which is your, you can say mean, but it's not real mean because mean of deterministic data is your average. But this is more like expected value of x. So I'm going to write expected value, and the moment expectation comes, it's probability. Okay. Then you also have sigma, which is your, that, right? Standard deviation, which is square root of variance. Now, what we are saying that if you take a range of mu plus minus sigma, 68, I'll say roughly, 68% of the data it will have, plus minus 2 sigma, it will be 95% of the data, and mu plus minus 3 sigma, 99% of the data will lie there. This is the reason the professors or the college universities professors, they use this like a lot. So suppose they fit on a normal distribution on your to calculate grades, right? So what happens, guys? Let's say, and definitely it will not be like symmetric. This normal distribution can be skewed. So they know that. So we have a mean somewhere here. So this is going to be mu. They know that in this there will be some sigma. So this is mu plus sigma. This will be mu plus 2 sigma, and this will be mu plus 3 sigma. And let's say this is mu minus sigma. And then they create bands. So this is going to be their favorite student, which is maybe 1 or 2, who is maybe 1 or 2, right? And they will be getting, let's say, A plus grade. Then they'll go to the next band, which is mu plus 2 sigma to mu plus 3 sigma. Focus, guys. So all those guys who are here, they are going to get, let's say, grade A, grade B, grade C, grade D. And everybody who is behind this are going to get what grade? F grade, which is a fail grade. First of all, this is just a high level overview of how grading system works. It's not that straightforward, by the way. This is just to give an example. And this is the most of the guys. Generally, F grade means you have to repeat the course and exam as well. Are you guys able to follow how normal distribution can help you? As a matter of fact, even the COVID quizzes were modeled as a normal distribution. Income can be modeled as a normal distribution. IITs, performance or result can be modeled as a normal distribution. So normal distribution is like bread and butter. Okay. The beauty about normal distribution is that it starts from negative. So it can fit all the real data from minus infinity to plus infinity. No other distribution can do justice for a continuous one. Okay. Now coming back, how we are going to use it. Okay. By the way, you understand what is the meaning of standard deviation? What is the interpretation of high standard deviation versus low standard deviation? Anybody? So for example, I give you two curves. Tell me which one is having the higher standard deviation. Higher standard deviation curve is which color, black or red? Where do you observe higher standard deviation? First one, right? Black. Those who are saying red, so please pay attention. Standard deviation means spreadness of the data, right? So how spreadness means amount of variation. So standard deviation, and you know why do we need standard deviation? Because can you see that the mean of the data, the peak of the data is same, right? So just saying mean, median, mode is not enough a lot of time, right? It's all same, but these two distributions are quite different. So the reason is that why standard deviation is required, because standard deviation talks about the amount of variation or dispersion, also known as dispersion, or also known as spread of data. Amount of variation or dispersion of the data or spread of data. So you guys can clearly see that this guy, the black one, is like quite varying, and the red one is like less varying. If you look at the similar range, that's why it is. Okay. Now, guys, there is a probability density function for the standard normal distribution. So what happens from the mean? So probability density function. Now you might be wondering what is it? Don't wonder much. I'll just use this jargon for you, although it should have been with you, but I can't do much about it. Probability density function is actually a mathematical function to represent the any distribution. So for normal distribution, you also have a probability distribution function, density function. Those who have done a little bit of random variable, they know that. So it is actually a mathematical equation. 1 upon root under 2 pi, sigma is outside, e to the power minus half x minus mu by sigma whole square, where x can be between this. Doesn't look, this looks better. Okay, guys. Now this is your normal distribution. This is not standard. Now the problem this guy has, this is normal distribution. Now, giving a little idea. Suppose you talk about a normal distribution curve, and this is how it is. P. I hope everybody knows this. The area under this curve is the total probability. Come on, right? If it represents all the different probabilities, the total data will have probability equal to 1. I think this is common sense. So then if it is symmetric about, let's say, about the center, then can I say that this area minus infinity to 0, let me take some time to shade it. How much this will be probability value? What is the area under this curve? What is this area? If total is 1, what is this area? Similarly, on the other side, you can say, what is it? You tell me. Another 0.5. So total is 1, right? So far with me, guys. Hello? Total is 1. 0.5 is 1. Since it is symmetric, it is easy to do some of these juggling. So you can say minus infinity to 0 is one part, and 0 to infinity it is another part, right? When it is symmetric. But look at this. Suppose this is a distribution, right? This is also normal distribution. It is like skewed distribution. Ideally, people don't say this is a normal distribution. Let me also tell you this. But let's say the distribution is not symmetric. Let's say this is the 0 here. See, about the peak, it is symmetric only, but it has shifted. Can you see that, guys? Hello? Are you with me? Now this is not at 0. It has shifted towards right. Now you tell me, if I ask what is this area? Minus infinity to 0. Minus infinity to 0. What is this area? Will it be easy for you to calculate? I think no. Because to find this area, and if you have done a little bit of maths, it means that you are going to integrate this guy from minus infinity to 0 dx, and you will die doing the integration. So statisticians, mathematicians, they agreed that, boss, we can't do it all the time. So they said, why don't we normalize this, make it a standard normal distribution? Doesn't matter what data we are getting, end of the day, we are going to make it look like what you see on the first one. And that's where we got the normal distribution to the standard normal distribution. Who will be doing this integration, right? It is doable, but it's not easily doable. So they thought, why don't we introduce standard normal distribution, which is in Python, you must have heard this, like, oh, I'll standardize the data. Have you heard this word? Normalize the data. The data scientists, they keep telling this all the time, which is overused or abused. But what is the interpretation of it? It means that you will take all the x value, then what you will do, you will subtract the mean and divide by sigma. And you will call a new variable called z. And this is where I introduce the z score. Have you ever observed this? At some point, x minus mu by sigma. So basically what you're doing, you're taking the whole data, subtract the mean and divide by sigma, means normalizing by sigma. This is known as, z value or z score, right? And what you're going to do with this, the idea is that if you take this and find expectation of z, which is like expectation of x minus mu by sigma, this is a little bit coming from random variable. So please excuse me for that, but I want to show you. So if you do the maths, it comes to be expectation of x minus expectation of mu 1 by sigma. Expectation of x is also average. If you remember what I've given on the top, see here. Oh, wow. Here. So using that, you write this as mu. Why I'm using curly braces, guys, sorry. And then expectation of anything constant is also mu. Cancel madi. So this is coming to 0. So the beauty of z score is that expectation of z is what? 0. Which means that mean for standard normal distribution is always 0. Hello? Mean for standard normal distribution is 0. It is a calculated mean. Always remember, it's not the natural mean coming from the data. You have standardized it. So don't miss this step in the whole scheme of things. I'll take a pause here, guys. You have done this extra step on your data to normalize it. And that's the reason that your expectation of z is coming to be 0. And likewise, sigma will come out to be 1, which I'm not deriving because it will take me to the intensive calculation on random variable, which is not there for you. Okay. Let's not go too mathematical actually. So far with me, guys. Now you might be wondering what is the benefit of this. So benefit is there, no? The moment you do this, you started with fxx mu sigma equal to 1 upon root under 2 pi sigma e to the power minus half x minus mu by sigma whole square. Now what you have done, my dear, you have taken this guy and you have calling this as z. Focus. So now suddenly what's happening? The transition is happening, and I'll write it will become fz. Z mu becomes 0, sigma becomes 1. And then you will write 1 upon root under 2 pi. Sigma is 1, so this will be a shorter one. E to the power minus z square by 2. Guys, does it look simpler than the one which I just showed you? So, right, your equation gets simpler and you can generate a table out of it, and that's where you're going to use it. So when I say table, then you will be looking at something. Yeah, it is difficult to remember. Since I'm teaching, I can, but that's the reason they're not hoping you to remember this. They're telling you forget about this. Why don't you learn this table? Now this is the jet score table, and we need to understand it in some time, but not now. What this table does, how it can help us, and blah blah blah. Right? Now tell me one thing. This is known as jet score table, Z score table. Okay, I'm not paying too much attention on. So it might be sounding like Z score, but it is not jet. It's not jet. It's Z score table or Z score table. Okay. Okay. So now if you see, guys, if you look at Z equal to 0, which is here, this is 0. Okay. So all the values of Z is coming here. Okay. On the left. Why it's not picking it up? All the values are coming on the left. Can you see Z value 0.1, 0.2, 0.3, and you have another set of values which are decimal values on the horizontal line. So you have two lines, vertical line and horizontal line. Let's say I'm trying to find a Z score for, let's say, some value. Like, let's say, what is the Z score for 1? So when the moment I say 1, it means that from 0 to 1, what is the value? So 0 to 1, how will you find? You can clearly see that this is your value. What is that? 0.3413. It's your probability. Okay. Don't get me wrong. It's your probability. Okay. So let's say if I fit a normal distribution curve, I take an example to make you understand this table. Let's say this is 0 and this is 1 and this is -1. I'm interested in finding the mu plus minus sigma. Guys, this is mu plus minus sigma. Na? Mu is 0 and sigma is 1. Mu plus minus sigma. Basically, you are trying to find 0 plus minus 1. Now, to get it, you can also understand that this is symmetric. If you find 0 to 1, you can also get the whole thing. And as this example say, this always talks about 0 to z, right? So 0 to 1, if I say, already I identified it. See, z 0 to 1 means in the chart, you have to find 1. What is the value for 1? Z equal to 1. What is this value, my dear? 0.3143. And since it is symmetric, it doesn't matter. The Z value for -1 to 0 will be same. Why area-wise if you look at that? It's not in this table. Do you see any negative value -1 or not? No, right? If you do the total, are you seeing a number which is very much familiar to you? Let me show you in case you are not able to recall. What is this number, guys? Mu plus minus sigma, 68.27. Are you able to almost getting the same? Hello? In percentage, what is it? 68.26% of the data. Interesting, no? So this table works, right? This table works. So what you can actually calculate and find and then answer, you are getting. Make sense, guys? Why it is 50%? Trigonometric question. And he was supposed to find this angle. So you're supposed to find this angle. And then what he did, he drew this extension. And then he was thinking that this will be 60. So this angle will be 180 minus 60, so 120. What is the basis for this? Are you observing it with the line? You're not looking at any condition, what angle, what is the triangle shape, right? So exactly you're doing the same. That sometimes people, like students, do this blunder. They just observe thing and then answer. Here observation doesn't work all the time. You have to go with the concept. The concept says that if it is 0 to 1, how will you find 0 to 1 in the z-score table? You will go and find what is the value for 1. Because this table gives you from 0 to z. So suppose you want to find 0 to 1, I can see that 0 to 1 is this. Then you might be wondering, what is this? You should ask that, what is this? What is this? So suppose you want to find till 1.5, right? Or let's say you want to find 1.05. How will you find 1.05? So you'll take 1 here, my dear, and 0.05 will look at here, and then you will draw two lines, and then where it is intersecting, that's the value. So what is the value, guys? 0.3531. Are you getting how to use this? This is for decimal places. Okay. Don't feel that if you're not getting it, what's going on. It's normal behavior with the normal distribution. Okay. Normal is not normal. It seems not, doesn't seem like that, right? Just trying to be, making the moment like normal doesn't seem to be normal, right? Why don't we do a question, right? So let me take this. Top 5% of applicants as measured by GRE scores, top 5% of applicants as measured by GRE scores will receive scholarships. If GRE is normally distributed with the mean 500 and the variance, right? Sigma square is variance. So sigma is 100, being smart. How high does your GRE score have to be to qualify for a scholarship? A real question, guys. We're trying to estimate it. Have to be to qualify for a scholarship. So this is for all those guys having American dream, going to US, going to US university, get a job, learn there, study there, and settle there, right? So they write GRE exam, and definitely those who have, I know some of the guys might be in US already, so they know it's not that easy. First of all, you need to have a lot of money in the bank, or you get a scholarship. There are only two options. Yeah. So did you understand the question, guys? You have a normal distribution. Mu is 500, sigma is 100. And they're asking that what should be the value, what should be the GRE score to qualify for a scholarship? You will not be able to do this right now. Let me do it for you. So guys, definitely when you look at this, it's a normal distribution. It's not a standard normal distribution. It's a normal distribution. Because why it is not a standard normal distribution? Still, awake and not sleepy. How do you realize that it is normal distribution, not a standard normal distribution? Come on, Janta, let me know. What is in standard normal distribution? What is the value of mu? Is it 500? It's normal distribution, right? Because mu is something non-zero and sigma is also not 1, it is 100. So it's normal distribution. Cool. Now I needed to convert into standard normal, right? So standard normal I have to get into. How will I get it? I'll calculate Z, which is x minus mu by sigma, which is basically x minus 500 by 100. Right, guys? So far with me? Now here we'll need a little bit of help from the question itself. They'll give you in the question itself that if you talk about that I need some data about the threshold, this threshold will be given from the data itself. And it's given, right, that 5% of the applicants are going to, receive the scholarship. Like, if you are having 96 percentile, 97 percentile, you're going to get the scholarship, right? Remember, those who have written CAT exam or any exam which are having percentile. Percentile means, suppose you are at 99, what does it mean? It means that 99% of the students are behind you, right? Hello. So similarly for 95%, this is your 95%, the whole of it 95, and this small part is your 5%. Let's say this is your 5%, and this all is your 95%. So those who are going to be in the pink area, they are going to get the scholarship. Hello guys, so far with me? So the major chunk is 95. Obviously, majority doesn't get scholarship, right? So far with me, 5%. Now this 5% cutoff will be given by the question itself. Generally, when I'll teach you confidence interval, hypothesis testing, right? So I will give you this. Don't worry about it. That 95% means you have a probability there, and that probability is going to get converted into a Z score, and that Z score will be 1.65. For the time being, just remember it. So alpha 0.05 gives you the alpha cutoff, right? And for this corresponding Z score is, for now, you just take it as a value. Later, I'll explain everything. Okay, it is 1.65, right? What is this coming? Because this is your confidence interval cutoff, and this is where the magic happens, okay? So for the time being, I'm just saying again and again, forget how I have reached to this, how they have given you this number. Later you will see. So now you have the Z score cutoff. Anybody who is having higher than this value will get the scholarship. So 1.65 x minus 500 by 100 If you calculate, it will come to 665, guys. Hello. So anyone who is scoring more than 665, they'll get a scholarship. Hello, guys, are you able to follow this question? So you might be wondering that how do you know that? Because see, if this is your cutoff, which is 1.65, then as you go towards the right, this value will increase now, right? Buddy, the question is how high does your GS score? When I say how high means how minimum you have to maintain to get the scholarship. Higher cutoff they're not asking, they're asking the cutoff, right? Suppose the qualifying marks is 665, you get the scholarship. Clear? Now I'll explain that, guys. How did you get that 1.65? Why don't you reverse engineering it? Where is 1.6? Here. 1.65 will be here, 0.05. Can we go there and see what is this value? My dear, come on. What is this value? This is what? 0.4505. Can you put into 2? This probability, how much is that? 91%, 90%? We need 95. So it is close, but not 100% close. Why I'm missing that? Because we are looking at a different chart altogether. 1.65. No, this is not correct. Something is fishy with the chart. There is another distribution, guys. Let me show you. Another table. Ideally, I use this table for getting this more better. So this is like, the problem is that this chart this chart can only be used, and that's why we'll not use, when something we are measuring from 0, right? Guys, remember they're saying 0 to Z. But if you are trying to do from minus infinity till here, right, this value. So then you should use this minus infinity to Z, right? This is the most appropriate chart. Now you tell me, where is 1.65? So this is 1.6 and 1.65. Now let's see. So this is a value, and the closer values are this. Now you are making sense, guys. So it is coming to what? Either you take this higher cutoff, 95.05, right? So there were no concept issue, guys. Don't get excited. It's just that we are looking at a different table. There are two formats to the table. One is from minus infinity to Z, and the other is from 0 to Z. But this time we needed what? From here or from starting? I think from starting. Now, guys, let me talk about important things, which is, I feel, the first question I generally ask, moving away from descriptive to inferential, is that what is the difference between descriptive and inferential statistics? Anyone want to take a shot at this, answering it? Inferential is conclusive, descriptive is unbiased measurement. Okay. But someone has answered in terms of what you will do with what, right? But what is the key difference? Descriptive, if you go with the literal meaning of it, describing your data. Now that data will be population or sample, that is another discussion, right? But if you are summarizing and presenting the data in a meaningful way to describe it without taking or making or generalizing any inferences based on the presented data. So inferential is conclusive. So if I can give you some pointers, guys, okay? So descriptive, if I may write, descriptive statistics, I'll just write stats, involves the summarization and presentation of data in a meaningful way. It's not like it's good for nothing. Just it describes the data, So what is the primary goal here, guys? Primary goal or objective is to describe the data. Obviously, with the help of mean, dispersion, measures of central tendency, leveraging, measures of central tendency. What is that, guys? What are the measures of central tendency? Mean, median, mode, right? Must have been taught. Measures of dispersion, right? Spreadness, variance, standard deviation, right? Measure of shape. What is measures of shape? I hope you must have been taught. Skewness, kurtosis, right? Etc. Differential is used when you want to make prediction or generalization about a population based on a sample. Yes, that's the application of inferential statistics, right? Why do we need inferential? That's the answer to that question. We are still understanding what's the difference between what is what. So guys, definitely all of the answers which you have given is correct. That descriptive is all about population, inferential is all about sample. But one thing which is very much, you have to be very much clear about that descriptive stats do not make any inferences. Okay. That's why I have a separate branch altogether. Do not, draw conclusions or inferences, but it doesn't mean that you will not find any logical conclusion, right, to Rn point. It does not draw any conclusion or inferences beyond what is presented in data. So basically means what? Generalizing it. What you see in the data, you tell it, right? It's an unbiased approach. They are going to inferential. So this is what descriptive is. I'll get into inferential. If you remember in school days in the English MCB main course book, those who have done CBSE, they would know. I don't know if it's still there or not, but I'm talking about more than a decade ago. So when I was in class 9, 10, right? So there we had a book called MCB, main course book. There they used to give some, 5 or 6 lines, right, in the paper, in the exam. And then they used to ask, what is the inference of this, these 4 or 5 lines, right? Remember, somebody remembers that, and then they used to give 5 option, 4 option, one would be correct, right? So obviously, read those 4 or 5 lines, right, and trying to make some conclusion on inferences about it. That's what you must have done in English, but it's a similar kind of situation for statistics as well. So inferential statistics, as the name suggests, you draw some inferences, right? The literal meaning of inferences is conclusion, some generalization. So I'll also keep talking and write so that I can save some time. Involve making inferences. And once you have done the inferences with you draw some conclusion about a population based on sample data. And that will be random sample. There are numerous ways of doing the random sampling. So what is the goal? The primary goal is to generalize findings or insights from a sample to a larger population, right? And then you also have some techniques there. Leveraging, what are the techniques generally we use, guys? Like as simple as doing hypothesis testing, right? So you actually form a hypothesis and you test it to come to a conclusion, using confidence interval concept, right? CI concept. And you will love it the way I'll teach you, I can promise. As simple as running some tests like t-test, right? ANOVA, analysis of variance, etc. Okay. So this is my introduction to the difference between these two guys. Now, at least we have come to a point where we know that descriptive is all about generalizing the data. Describing the data. Inferential is all about making inferences or generalization about a larger data set from a sample of those, right? That is clear. If that is clear, guys, so then I'll give you a movie recommendation. And this is just one summary, which I have already written. I don't want to write. See, so if I have to summarize it in a nutshell, descriptive talks about describing the visible characteristics of a data, which can be a population or sample. So not always be like stubborn, oh, I'll only do population with. You can also find descriptive statistics for sample. Who is stopping you? Meanwhile, inferential talks about inferences or generalization. Look at the green highlighter. About a larger data set based on sample of those, and that sample will be random. There are a lot of samples, stratified, strategic, random, simple random. There are a lot of things are there. Let me talk about sample versus population. Okay. So whenever we talk about sampling, so sampling is very, very important for any inferential statistics, right? Any sort of test. You cannot test everybody. Okay. So let's say you are looking at a population, which is the country population. India has how many people? How many we are? 1.4 or we are now 1.5? How is it? 1.4, 1.5. What is it? 1.6. Okay. So 160 crores. So let's say if I try to measure something, 160 crore people, this will be quite a lot of data, isn't it? Hello? And quite a lot of, if you are referring to what is India's population in 2023, I think it is saying 1.43 or 1.44, not 1.6. So yeah, it is, we are close to 1.4243. Anyway, so doesn't matter for my example. Suppose I ask you to go and talk to everybody and ask their mathematics marks, right? And give me the mean of maths for Indians who have studied maths, means except those guys who are in, let's say, and grade wise. So grade 1, average marks, grade 2, grade 4. Do you think it is even possible to do that? I think no. I'm asking you to go and talk to everybody, right? Oh, okay, let me take a recent example. Election just concluded, right? You must have heard about exit poll. One of the famous things happens on media. Exit poll. Anybody has any idea? Exit poll. Exit poll is like they do give you, agencies. They do the polling, and they do the random polling, random sampling of the voters. They ask in a constituency that, okay, tell us what do you think. They don't go and ask whom did you vote for. Was it party A and I'll not take any party name. So let's say there are three parties, party ABC. Whom did you vote for? They don't ask. They have a very amazing set of questions, they call questionnaire, and they go and they do this survey. But do you think is it possible to, let's say, just so I was in Indore, so MP Indore, let's say we go to Vijayanagar. Anybody from Indore, say hi. So let's say an MP election just concluded. Suppose this is a nice place in MP Indore. So even for a Vijayanagar population, let's say the population is, maybe let's say 20 lakhs. Okay. Hypothetically, I'm just making some numbers. Is it easy to go and talk to everybody who are 18 plus who can vote? We can vote 18 plus or 21 plus. My GK has gone, I think 18 plus is the voter. So 18 plus guys can vote. You're not going to ask all the voters that whom did you vote for, right? It's not possible. So what this agency do, guys, agency do the random sampling of voters. So what they do, they are going to do random sampling of voters. And if I'm correct, they also pay the one who participate in it, but they never accept it, by the way. So agencies do random sampling of voters. They'll do in Vijayanagar and ask a set of questions to gauge the sentiment, right? Ask a set of questions to gauge the sentiment and tie back to which party these guys voted for, right? And then what happens, they prepare a nice summary. And if you have seen, you must have seen something like this. I cannot show you who is getting what, but I can definitely show you how does it look like, right? Have you seen this? Hello. So can you see, if I take the first number, 120 to 140, let's say this is party A, party B, party C, party D, whatever. It seems that party A has a clear majority in most of the agencies. So coming back to this example, so politicizing this, who is what in this list, let's focus on our concept. So what is this 122 to 140? What do you mean by that? So these agency, what they do, right? Let's understand the process. 120 to 140, right, is the range they are given. Isn't a range that minimum party A will get 122 seats and maximum they are going to get 140. Hello, so far with me, guys? This is what we call it as confidence interval. Interesting. So we have been seeing these exit polls for long. This is known as confidence interval, and they give a confidence score also that we feel 95% chances that party A will get these many seats. This is known as confidence interval estimate. It's an estimate, right? Because you are not talking to everybody. You are talking to a sample of people. You are asking those questions, right? You are asking those questions and you are coming to a conclusion that, okay, party A will get these many seats. Because don't forget that you did some sampling here, right? This is how sampling looks like. You go to a constituency, you will pick and ask questions. This is your sample, right? And then you come back to generalize something about that population. Point estimate versus confidence interval estimate. Point estimate would be like, okay, I will say party A will get 130 seats, period. You cannot exactly predict it. 130 seats. Astrologer do that. I think party A will get 130 seats. It is a point estimate, one value, single value. That is like, getting the mean. Generally, people say this will be the mean of the sample. And then I am saying that this will become population. So mean of the population I am predicting. So on an average, I feel party will get 130. But tell me, getting 130 correct is tough or not? Tell me. If the party gets 132, you're wrong. If the party get 130, 28, you're wrong. So point estimate, you cannot, put a confidence to it. So that's why statistically, we generally go with confidence interval concept. Now, if I'm getting 132 or 128, still both the options are going to fall in here. Hello. And your analysis is still correct. That happens with clinical trials in vaccines as well. When the COVID hit us, so a lot of vaccine trials would have happened. And I'll take that example. I talked about that case study that vaccine trials, right? Vaccine trials are not going to be 100% accurate. And when the pandemic happens, right? It's a mahamari. It's very tough because you're running against the clock, right? You need to get a vaccine in the market. So you cannot be like waiting for 99.99% accuracy, right? You will go with some confidence interval. Generally, they use 95 because it's related to health. You cannot administer something to someone who are having some comorbidities. They might die, right? Rather than they die with the virus, they die because of your medicine. So you have to be very careful. But they do all those clinical trials to come to the range of efficacy. So that's what is the efficacy of the medicine, how effective it is, it's a score. So that score, if it comes in a threshold, you go and release the vaccine in the market. Hello? And then you put in the batch production. So that's the difference between the point estimate and the confidence interval range. I'll deliberate more on it. But point estimate does not provide a room of error. There's no margin of error. 130 means 130. But confidence interval does provide margin of error. You can make mistake. And that you can also set it up. Suppose you say 80% confidence interval, then your range will be like 100 to 140 or 100 to 160. Are you feeling, guys? Then you will say that, what is this? You cannot have this much of range, right? 100 to 160, and then some party will, the majority is like only 60, let's say. Majority to form a government is 70, and you are putting a range of 100 to 200. Error cannot be the majority, right? Are you getting my point, what I'm saying? Let's say to form the government, the majority is like 70. You are putting the range of 100, that the gap is 100. So that's not an appropriate study. So that's where range, how much we should keep a percentage, 95, 99, 90. Generally, these are the confidence interval levels, 95, 90, 99. But that in any exit poll, they follow a very good set of approaches to come a number, which is your confidence interval. That's what they show in the TV, which you are seeing, right? And they also claim that my analysis depends on blah, blah, blah thing, right? That's why if you see, some of the guys are like rock star. Can you see these guys? I am telling you, you'll get exactly. This is like idiot. They must be new. So definitely these are the top players, right? See voter, I have been seeing since my childhood days. But this is like new nation, whatever. Can you see that? They are giving the point estimate.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Right. And there we understood that there can be two types of estimate. One is point estimate and other is confidence and interval estimate. So we are going to extend this conversation further. Okay. I think there was one question, right? This family income, if the poverty level is this, what percent of population lives in poverty? So here, mu is what? $25,000. Sigma is 10,000. So Z is what? X minus mu by sigma. If the poverty level is this, which is 10,000 minus 25,000 by sigma 10,000. So that will be minus 15,000 by 10,000. You will get minus 1.5, right? That's what you're getting. Now you're looking for a negative table. So try to understand this. Let's say this is your normal distribution, right? Standardized normal distribution. And let's say this is your, after doing this, this is 0. Let's say this is your 1.5 Z score, and this is minus 1.5. Definitely, if you keep going on the left-hand side, these are the guys who are going to be below poverty level, right? It is as good as saying that these are the guys, hello, because it's symmetric. So you need area from minus infinity to minus 1.5. What you can do, you can find area of 0 to 1.5. You find this area that will give you the probability and subtract from 0.5 now. So you have to use this table, my dear. So where is 1.5? It is 0.4332, right? So then how much is that? 0 to 1.5 is how much? 0.4332. Okay. And 0.5 minus 0.4332 is how much? If I can write 0.5 minus 0.4332 equal to 0.668 into 100%. If you do, how much is that? 6.68% coming to the same answer. Now, if you're wondering what is it, it's very simple. What I've done, I have calculated this area from the table, the Z-score table. It comes to what? 0.4332. If you subtract, so this area is going to be the same as this area, right? It's symmetric. So what I've done, I've taken the whole area, which is from here to here, and that is 0.5. You remember 0.5, 0.51? I've taken 0.5 and subtracted this part. I have gotten this part. Clear? It was easy question. The only complication was how to calculate the area using the same table, right? You could not have used this table because you don't have minus infinity. I think this is a typo from my side. You're right. It is 0 to Z, right? 0 to Z. It's not from minus infinity. Ideally, it is minus infinity. Sorry, my bad. It is from minus infinity because if you see here, it is 0.5. So if I do that, minus infinity to 0 is 0.5 only. No? So this, I wrote it correct. No, there's no typo from my side. Sorry, I got confused. But this is from minus infinity to Z, but you don't have somewhere minus 1.5 here. So what you can do, you can go till the last, like others are doing. And till the last, if you go, so let's say this is 1.5, subtract this from 1.5, you will get the same answer. I think Venu has done similar approach, right, Venu? So there are multiple ways to reach to the same answer. Let me show you. 0.9332. See, coming. Now I'll move on to the concept of, so I was saying, right, that exit poll example, right? So just to extend a little more, so for the exit poll, a point estimate looks like, let's say there are 300 seats. So now I'll take my own example. You have three party A, B, party C. Let's say you are saying party A will get 180 seats, party B will get 80 seats, and party C will get 40. Total to 300 if you do the maths. This is what we call it as what? Point estimate. What? Point estimate. You are giving a single value that this will happen exactly the same. So there we don't have any, margin of error, right? But on contrary, if you go to the other side of the story where we are saying we'll talk about, so this is point estimate. Let's say we talk about confidence interval. So what we do, we add a margin of error to the point estimate and we develop confidence interval. And then we have different levels of confidence that, okay, you will say 90%, 95%, 99%, which one you are going to say. So for example, if I look at party A, so I'll say, okay, party A will get 170 to 190 seats. So let me rewrite this, party A, party B. and party C. Let's say we say party A would get 170 to 190 seats. So what you've done, my dear, is that you've added a margin of error. You have added a margin of error. Obviously, it's still the mean, the average is what? 180. But you are not saying 180, you are saying 170 to 190, which means that you are going with certain alpha. Let's say alpha is 95% confidence. Don't worry, I'll explain that. Alpha is, 95 means 0.05. You have to do opposite. And alpha is known as level of significance. Similarly, for party B, you will say, 70 to 90. Party C will say 35 to 45, something like this, right? This is known as interval estimate, confidence interval estimate. You have a range there. So I have a very good example to give you the definition of confidence interval. I always show that. So, and you will love it. Can you see that? So there are two people, right? There are two images. Can you see that? So I have already kept the concept and notes here. But if you see here, look at the first point estimate. Let's say you go for fishing, right? You go for fishing and you're using a more like a spear to fish, right? So you think that, oh, I'll just, hit the fish with this, right? What is the margin of error in this? Quite a lot of, like, there's no margin of error, right? Means you have to make a mistake. Chances are very high, guys. You agree with me? Then there are another image on the right hand side that talks about confidence interval, that you have a fishing net. Tell me which option will give you more number of fish, more number of fishes. Chances of you get a fish, obviously the net one, the confidence interval, because it will place you in the range. Chances are very high to compare against with that you will get exactly that fish. So this is a very cool image to understand that confidence interval, refers to the probability that a population parameter will fall between a set of values, right? And that set of values is like your range, your interval, and that will fall for a fixed or certain proportion of times. So when you say 95% confidence interval, what do you mean by that? It means that if you do this activity of exit polling, 95% times I will fall in this range. I will not be in this range for how much time? 5%. Means still there will be some error, there will be mistakes, but you will be 95% within the range. And you will be 5% outside the range. Means mistakes have been done, means your exit polling gone wrong. Are you getting it? So that's how you define confidence interval. So see, this is a normal distribution curve, and this is 95% confidence interval, which I mean to say alpha is 0.05. Again, look at this. And you can clearly see that if alpha is 0.05, so it is two tail. So you have divided this into alpha by 2. So one is for the left tail, right? If you do alpha by 2, how much is that, guys? 0.025. In percentage, it will be 2.5%. The right tail, you have alpha by 2, so 0.025 equal to 2.5%. Total is 5%. So if you look at the limit, right, this is your upper limit, this is your lower limit. What we are saying that, let's say we gotten a population mean, right, and we say that the population mean, we are trying to estimate, there is 95% chance, listen to me, 95% chance that the population mean will fall between what? These lower and upper limit. 90%, 95% chance is your population mean will fall between this. This is your confidence interval, right? Just like in this example, I had mentioned that let's say your mean is 180, and when I give a range of like 170 to 190, I am sure that 95% times you will get a value 180 lying in between this range. Clear? Don't worry, I have give you the formula, derivation, everything, but did you understand the concept? Point estimate is used in which cases then? Because CI has a broader approach. So whenever you are interested in getting a single value, you are not interested in giving a confidence interval, you can go and use it. For example, For example, let's say you want to estimate the average height of a population, right? You don't need to really go and give them, let's say estimating average height of a population. So in this case, point estimate can be might be the sample mean height, right? So you take a sample, you find the average, that will be your point estimate for the population. Okay. Now, whenever you want to add, and that's exactly being done now. You have taken a sample in the exit polling also, right? Remember? And you have done the average number of seats I feel from the sample it should come. This is a point estimate. So it's not like that point estimate is not being used. You are using point estimate in the more like a first step. And that becomes the base for your confidence interval, which you will realize that let's say if I have a average sample height, let's say some value X, right? Sample mean height or sample average height. And now rather than you want to represent this into a confidence interval manner or confidence interval representation, you want to say, oh no, I don't want to say average height. I would like to say 95% confidence that the true population height is between the lower limit and the upper limit. So it's more likely to, go from point estimate to confidence interval when you want to give a more like a certainty of getting a value, right? If you are not going to give that certainty of a value, you just want to estimate it and just say it out, you can use sample mean, and that's where point estimate can be used everywhere. You're getting my point? It's not about that it's like A versus B. It's like A and then how we can add a layer of certainty to A, and that becomes your confidence interval. Point estimate, single value you are estimating. Confidence interval, when you want to give a range of values and showing that, okay, you are 95% sure that, it will fall in that range. So now, why don't we get into some questions then? How to calculate confidence interval? See, I'm telling you mathematics behind the scene as well. Now, guys, you always remember that you have a Z-score for different confidence level. Okay. Confidence level is different from confidence interval. Always remember that. So this is your confidence level. This is as good as saying your 1 minus alpha, right? So 95% chance is 0.95. Z-score is 1.96. And you can see this in your, right, 1.96 now. So 1.9, where is 0.6 here? So you can come here, see. So what is the value you're getting, guys? 0.9750, right? You are here. And this is your 2.5%. Do the maths. If you subtract 1.9750, you'll get 2.5 in percentage. And similarly, we'll have other 2.5. So are you getting 1.96 means 95%. 95% chance, right? So these are the values you should always remember. It should be on your fingertips. So once you have the confidence level and the Z-score, so the formula becomes, to be honest, very easy. So the formula says, let me give you, confidence interval CI is equal to X bar plus minus Z S by root under N, where X bar is the mean, sample mean, Z is the chosen Z value, right? I'll also give an arrow to take you the right place. Yeah. S is what, my dear? S is your standard error. Standard error. It's not standard deviation, it's standard error. I'll come to that. And N is the sample size. Clear? So now you might be interested in upper limit and lower limit. So you can calculate now. So what is going to be upper limit? It is going to be upper limit for confidence interval X bar plus Z score S by root under N to multiply. What is going to be a lower limit? Confidence interval X bar minus S by root under N. So now, guys, this is known as standard error of mean. Okay, let's talk about a little bit more. Standard error of mean. So what is the meaning of it? So let me write one line and you'll understand. This is a measure. Again, this is equal to a standard deviation only, but not like typical standard deviation. You have to always say standard deviation of what? So this is measure of variability associated with sample mean when it is used to estimate the population mean. So suppose you have a population, right? This is your population, and you have a sample. This is your sample. Hello. And you can have multiple samples, right? Every time you will get a sample mean, sample one, sample two. So far with me, guys, right? If you do that random sampling, population mean is not going to change, right? Let's say this is your mu p, mu population, mu pop. So every time the delta between mu pop and what you have estimated, there will be some number, let's say A, mu pop minus x2 bar, B, mu pop minus x3 bar, C. Hello? If this delta, if you find standard deviation for ABC, that becomes your standard error. And dot, 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 dot. Are you getting that? That measure of variability associated with the, when you're trying to estimate, okay, the difference always, okay, that becomes your standard error. Are we clear, guys? And I'm going to give the formula C, right? Correct, guys? So obviously, you can see what I was saying, right? Xi is your different sample mean, and you're finding that. So what we are trying to do, we are finding x1 minus mu, x2 minus mu, x3 minus mu. No, this is a different formula. So we are not actually subtracting from standard error. We are not subtracting from sample mean. As for this formula, what we are doing, I'm just also contemplating that only somewhere, that sigma divided by root under n. Yeah, so that's correct only now. You are right, you are right. So n is the sample size. This, what I've written, this whole thing is your standard error. So this S, okay, let me update this, because then you will get confused. You're right. This whole thing is your standard error. This is your standard error. Okay. But guys, I think this is something I need to just validate, but this is the formula of standard error of the mean. There is no doubt about it. Standard error of the mean, but I'll validate it. Okay. For the now, for the time being, this formula can be a little tricky time to time. And what is n, by the way, guys? N is the size of the population. Rest terms, you know, right? Rest of the terms, you know. But I'll get back to that again. I need to validate from a. So every time all the resources will have, you know, S by root under n is the standard error of the mean. Okay. Every time, some of the times, you know, the portals are not that great. They also make slight mistake in the formula, not concept. But this is how we go about it. For the time being, guys, let's go into the question so that you have a certain idea that how do we calculate confidence interval. Okay. So let's say if I give you, and I can give you like an example rather than calculating it. So for example, not a question, but for example, if you look at confidence interval, suppose I say sample mean is 86, Z is 1.96, and standard error of the mean is 6.2 by 46 total, right? 46 your sample sets. How will you do it? This is your sample mean. X bar and mu are not same. Mu is for population mean, right? This is for population, and X bar is for sample mean. They are not same. Calculate the margin. So give me the upper limit, give me the lower limit, and tell me the answer. Do the maths. By the way, guys, tell me one thing, and maybe Soumya, you only tell me what this is standard error of the mean, but what is this S? This is your sample standard deviation, right? And the moment you divide by root under n, it becomes the standard error of the mean. Okay? Standard error of the mean. So that's the difference. Okay, by the way, come here. So what is it? 86 plus 1.96. Why you guys are thinking so much, right? 46. Come on. Someone can give me this, or I can write myself. 86 plus, and guys, this will be root under now 46. Root, I don't know, I can take it in one note. But guys, anybody has solved it? This is root under. So I have the answer for the upper limit as 87.79. Anybody who gotten this? So this is what you will get. For the lower limit, you have to do the same thing, and it should be 84.21, right? So if you look at this formula, guys, x bar plus minus, z into s by root under n. This is your confidence interval. If you deliberate little more, you'll realize that as the sample size increases, right, confidence interval become narrow. It's obvious, right? It's a general thumb rule, right? Should become more narrow and vice versa, right? Because you have more data points to get more exact answers. So your confidence interval can be narrow and you can still achieve better accuracy. Let me give a question here. Do it, guys. In a sample of 40 light bulbs, the mean lifetime is 5,000 hours. Okay. 40 light bulbs, mean is 5,000 hours and the standard deviation is 400 hours. Compute a 90% confidence interval for the average lifetime of the bulbs. Get to it. And I'm giving you another question. I can also help you. See here, whenever you're looking on any confidence interval, generally there is a concept of central limit theorem, which says that to apply any concept of normal distribution, you have to have your distribution normal. And that can only be possible that if n is greater than 30, which is your sample size, we can use z-score equal to much 90%, right? So it is what, how much is the value? 1 point, I gave, 1.676. Look at that table, 90%, 1.645, sorry. Z-score is what? 1.645. So if n is not more than 30, then you will not be able to use this. There are some rules. Now, if you use this, so you have the z-score, you have a sample size n40, you have mean lifetime, how much? 5,000. You have standard deviation S, sample standard deviation is how much? 400. So what is going to be your confidence interval? It will be x bar plus minus z score. Listen to me, guys. S by root under n, right? Someone should have done by now. So someone should have done it. How much is that? 1.645 into 400 by 40, root under 40. What is it, guys? What is the range coming out to be? Upper limit will be how much and lower limit will be how much? So upper limit is 4895 or lower limit. Which one is it, Siddharth? Lower. Lower I am getting. No, I think I made some calculation mistake. What is square root of 40? Ah, it works. Wow, this is good, yeah. Okay. So 400 divided by square root of 40. I can use it. This is cool. Wow, this is good, yeah. Then what I can do, I can multiply 1.645 into this with this, right? So, and I also want to add 5,000 plus, right, guys? This is my one note equation. I am getting 5104. Okay, I'll copy and paste. I'll just add a minus. Here is your 4895. I think guys are right only, no? So the answer is, so apparently my answer key is wrong, which I was looking at. 5104 and 4896, right, guys? Come on. So upper limit is, so that's why I don't trust these question and the answer keys. You have to be careful. I'm only interested in the question, but this is the range, guys. If you're not getting it, whatever you have done is correct. Okay. I think it's a good place to stop. But guys, let me take a quick feedback. Did you understand the point estimate and the confidence interval? I think you cannot say no, right? This is the, so yeah, this is how, generally any statisticians, right? They come up with this kind of approach to estimate the population characteristics with the help of sample, right? So you can clearly observe in question like this, you are not looking at all the bulbs. Let's interpret it now. You're not looking at all the bulbs. You're only looking at 40 bulbs, right? And taking the sample mean of those bulbs, standard deviation of those bulbs, hours, right? And then you are coming with the confidence of saying that I feel all the bulbs in the population will either last 4896 to 5104 hours. Interesting, right? So looking at batches, you are coming and generalizing the whole, you are looking at this batch sample and then generalizing it to the whole population in that batch. So in manufacturing, you use confidence interval like anything, the quality assurance, the quality engineers, they use a lot. So if you are not finding a lot of issues, right, you feel that average lifetime is X, right? You can generalize and you can generalize it to the population. So using this sample mean and putting a buffer, which is your margin of error. This is your margin of error, no, guys? You forgot? This is your margin of error, right? So let me ask one question. I'll talk about the next very important topic. Later on, guys, you remember I said n should be greater than 30, sample size should be greater than 30, then only we can use that score. But nobody asked me that what if sample size is less than 30? So if the sample size is less than 30, you will be using the t distribution and you will be using a t-score. Hello. So I'm giving a note because I have not talked about t-distribution or t-test, but I'll give as a note. Please keep it with you. You don't need to write, it's going to be in the notes. So I'll write a note. Let's say we have one small set of data or one small set of sample, which is, let's say n is less than 30, then t distribution in place of z distribution or normal distribution instead of normal distribution is used to construct the confidence interval. Okay, guys, clear? So if the sample size is less than 30, then t distribution instead of normal distribution, so I'm going to highlight it as like pink or purple, to construct the confidence interval. That's how you construct the confidence interval when the n is less than 30. You have another t distribution. Your formula will change. Your formula will look like this, my dear. X bar plus minus. Here you will bring t distribution or t score, t distribution score into same thing, S by root under F. Nothing changes. Only thing is changing is what, my dear? This Z score will be replaced with t score. Clear? But I'll get back to that. Now I'm interested in more on hypothesis testing. Very interesting topic. Hypothesis, right? In India, people are always ready with their own hypothesis. So a simple hypothesis can be that, which I always take this as an example, that there is a man who goes for a trial. A man goes to a trial where he is being tried. This is a very classical example I take. Where he is being tried for the murder of his wife. I know it's, discussing this example not a good idea, but I'm bound to take this example, right? What do you guys think? Girls, ladies, let me know. Ideally, when I say this, without getting into anything, 95% will say, okay, definitely he would have done it. A man goes to a trial where he's being tried for the murder. The moment you see murder of his wife, living in today's society, we believe that this is 99% correct. But do you think, judiciary works on this principle? Do you think the judge in the court will behave like you? Never ever. There's a rule, right, in the law, and obviously I'm again, just like we Indians are opinionated, right? I don't have any idea about law and order, but I'm just reading some lines and telling you this is how they proceed any cases in the world, not in India, across the globe. Judge will only work on the documents, and documents is always under the administration. How they present it, what they presented, that is going to decide the fate of the case. That's how reality is. Okay, there's no emotion attached to it. But when I say this statement, a lot of people, if you go and say this in society, right, the moment something happens, right, 100% people will start believing that this man was that, blah, 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 100% he has murdered his wife. But this is a hypothesis. You need to test it. So if you want to test it, then you have to form two set of hypotheses. And that's where you must have heard in hypothesis, there is one known as null hypothesis. So you have to first frame null hypothesis. Now you tell me guys, what should be the null hypothesis in this case? H naught. In this case, the null hypothesis is what? Not guilty. The court will proceed or initiate this discussion, right, with the guy saying not guilty. Right? At the moment, have you seen in the movie, right? I think we learn a lot from movies, but few things are correct. The judge will, just to save the court time of the court, they'll ask the person that, do you accept that you are guilty or not? Like there's a very typical language, right? The lawyer will tell you how to respond. If the person himself accepts guilty, then nothing to be done, right? So obviously he will be just punished for it. Agree? So that the first thing they ask to the person itself, that are you guilty or not? Do you accept that you have done it? If you have not done it, then the court will accept it as the null hypothesis. Null hypothesis means natural. Null means no change. Always remember that. Someone can ask this in interview. Null means no change. Tell me, do you really think that everybody, right, waking up and killing their wives? I don't think so. Right? Every man in the world, every day they wake up and they plan to kill their wife. I don't think so. Right? What is rare is you're going to be alternate hypothesis. What is very common to happen in this society is going to be null hypothesis. So what is common in this world? Like you sleep in the night, sleep during night. That's common. I know some no, we are owls. We don't sleep in during night. We wake up in the 2 a.m. in the night, and then they'll sleep around 6 a.m. in the morning. So I'm not talking about exception, I'm talking about natural. What is natural in this world? You sleep during night and you wake up in the morning. Guys, hello, you agree? That's your normal. Similarly, this is also normal that man is not going to kill his wife, right? This is normal. Still it is normal. I know it's hard to believe it, but then the woman would not have got married, right? There's no point if you know you are going to die. So definitely this is all normal. That's why the hypothesis should be very carefully framed, right? Null hypothesis is not guilty because of this normal natural phenomena that nobody wants to kill nobody, right? Trust me, still this is the philosophy. And trust me, building hypothesis is a lot of philosophy. Then alternate hypothesis. Alternate will be what? There is some change. Change in what? Change in the normal behavior, right? And that will be HA. Sometimes people also write H1. So both these notations are there. And well, looks weird. HA or H1, and it is going to be killed. Hello. And now you will start with the data to test this assumption that, okay, guilty or not guilty, and you're going to start with the whole data-driven approach to come to a conclusion. We always want to prove the null hypothesis is true. If we are failing to do it, then alternate wins. Clear? So you lose the case while trying winning it, right? Have you seen this also a defendant? If you are getting convicted in something, so not convicted, sorry. If you're getting tried for something which you have done or not, still you will get a defendant, right? You are going to be defendant, right? Right? Victim, I don't know what are the words, but defendant means that the person who is getting blamed, right? That person needs to be defended. So naturally, you feel that this person, even you can feel that, okay, you need to still defend that person because that's not natural for killing, right? A person. So null hypothesis is going to be the idea to win that so that you prove that person is not guilty. In case we fail to prove it, then he will be getting convicted and he will be getting the punishment. Simple. So, see, we were discussing hypothesis, right? So, null hypothesis means no change, no impact on treatment, no change, nothing has been done. Okay, you're doing a test like in a pharmaceutical company, you are doing a control test group. What is the effect of treatment on your patient? If it is null, means no effect, right? So that's where comes your null hypothesis. Now, let me get into the little more of the details. You should know that hypothesis testing is basically an assumption, right? Always remember that. Let me give you as a note, else you will forget. Hypothesis testing, my screen is up, right? Is basically an assumption that we make about the population parameter. It's an assumption that this will happen, that will happen. Till the time you are done the test, complete testing, it's still an assumption. Okay. If I continue right, hypothesis testing evaluates two mutually exclusive statements. Correct, guys? H0 and H1. What is the meaning of mutually exclusive? Means if H0 is correct, H1 will be false. Right, guys? Correct? Two mutually exclusive statements you are going to evaluate about population to determine which statement is best supported by the sample data. Okay. Now, how does hypothesis testing work, right? I want to show you. And to show that, I have to use an image. Let me show you this. This is very, very important, guys. Again, you're going to fit a normal distribution, right? You can see that this is for two sides, by the way. Can you see two tails are red? This is for two sides. Suppose you say alpha equal to 0.05, right? That's your level of significance. In another 5-10 minutes, I'll explain in full detail. But tell me for alpha 0.05, alpha by 2 is what? I have just calculated. So in terms of percentage, it is 2.5, 2.5, guys, correct? For 95% confidence interval, you have alpha by 2 is equal to 2.5. So guys, if you look at this, I'll start shading. This is your happy region. That's your confidence interval, now, guys. This green shade, the bigger area. See, this is your confidence interval region. You can say this is your happy region or CI region, where you will say that if anything which you're trying to test is going to fall in this place or not, right? Now, what happens now, whenever you're trying to form the hypothesis, I'm giving one example of hypothesis, that average height of the sample is equal to the national average height, which is your population height, right, guys? Come on. If you're comparing sample height with national average height, is your population height. So ideally, you will believe that average height of us, like let's say, and this is a sample, and the data you're looking like all the adults, male, between age 18 to 25, right? Something like that, or 20 to 25. You can decide the test. So you are saying that if you try to take a sample out of this population for the height of the average height of the adults male, we believe ideally it will be same. That's why it is part of what hypothesis? H0. If your hypothesis is true, listen to me. So you have a alpha. Always remember that. You have a alpha, which is your level of significance. Remember that. In this study, I have fixed it to 0.05. Now there are certain rules. If your p-value, which is denoted as p, is less than alpha, listen to me, less than alpha, sometimes people also write less than equal to alpha, you are gonna reject the null hypothesis. Listen to me. Don't worry how, why. I'll explain, you will understand. If your p-value is greater than alpha, you accept the null hypothesis. P greater than alpha, you have to accept. Now the question comes, bro, I'm going there only. What is p-value? So what is p-value? Let's answer that. So p-value is the probability. P stands for probability of rejecting a null hypothesis when it is proven to be true, right? So it is the probability of rejecting a null hypothesis when the hypothesis is proven true. If p-value is less than or equal to, as let me highlight, p-value is equal to or less than the significance level alpha, then the null hypothesis is inconsistent and needs to be rejected. I think that's the same thing I've written, guys. Here, if p is less than equal to alpha, you are going to reject the null hypothesis. But this is a little tricky. And Anthony, everyone, please hold on to your question. Let me explain. I'm not done. To explain this, I need to show you one cool example with the help of this chart. I think you are going to understand like this. Tell me one thing. I'm talking about two scenarios. Scenario number one, a dog bites a man. You must have had You must have seen some news in the videos, right? Where the pet dogs in the left, they are doing all the kind of nonsense things. Have you seen it, guys? A dog bites a man. Do you think it's going to be here or in the tail? What do you say? There are two options on the plate. Most likely observation, most unlikely observation. Very unlikely. It is going to be in the tail or it is going to be in the peak. Why it will be in the tail? A dog bites a man is a natural phenomena. It will always be somewhere coming as a most likely observation. In India, every day a dog is biting somebody, right? It's a common phenomenon. The second phenomena I'll give you is a man bites a dog. The moment a man bites a dog, it becomes the breaking news. A man bites a dog is like likely. What do you think? A man bites a dog is very unlikely. It's like some psychotic behavior, right? That's how we put it. But I don't see this is going to be a common phenomenon, right? You guys agree or not? Hello? So it will be coming somewhere in the tail. Now you tell me, a dog biting a man is like a non-hypothesis. It's a normal behavior. To reject it, you have to come to the tail. Hello? Listen to me. A man biting a dog, you have to come here, and that is in the tail, very unlikely. So you will come here. Now, you know that you have a cutoff, remember? And you have another cutoff here. At least you know this, right? You know that this part of the graph is your green region. If there is an easy way to create these diagram and all, I would have done all myself. So now if you see here, this is the most likely to happen. That's why it's green zone. This is this purple zone where the unlikely things happen. Agree? Everybody so far with me? Don't lose it. Keep holding on the thoughts, right? Now tell me, this is your reason of what? 0.025. Remember? Alpha by 2. And this is also 0.025. This guy is 95%. And this guy is how much? 2.5, 2.5. Don't forget that. Okay. Now you have a alpha. Alpha is how much? 0.05. You are saying that if your p-value, probability value, is less than equal to alpha, you reject. Remember that. Tell me, p-value is probability value. This is going to be the highest probability. Look on the y-axis, right? So if this is less than alpha, your alpha is what? Fixed. You fixed it. Somebody asking me alpha is going to be fixed. Yeah, you fix it, na. Your alpha is 0.05, or for two tail, you will fix it to 0.025. Depends on you. But let's keep it for 0.05. If you get any value which is less than that, you will automatically land in this region where you have the less probability. Your cutoff less than means what? You are going in this red zone, na? This purple zone. Everybody, I need your yes, no, good to go, right? The moment you say less than 0.05, so see, if I can give you some numbers, then you will understand the beauty. Let's say this is like, 0.3, this is like 0.2, this is like 0.1, this guy will be like 0.05, right? If you go lesser than this, you will come more toward the tail. Now, are you feeling it, guys? People don't feel, because they don't look at this. This is y-axis is probability only, no? Because these examples combining everything into one story or narrative will not find anywhere. Maybe one guy after doing 1 hour of search, you'll find. Obviously, I'm not there, so you'll find someone X, Y, Z. But it's very tough. Trust me on that. Understanding the p-value, understanding the alpha, and understanding where to reject visually. Explaining this in visually is very tough. And if you're able to explain, it's very easy then. Why, when I say this line, it means it go to this region. Alpha is 0.05, which is your cutoff, or alpha by 2. What do you set? If you want to go lower than this, you will don't go there. Because what in our head happens now, you always think like a kid, x-axis, y-axis. Suppose this is your cutoff, let's say alpha. When I write less than equal to alpha, your brain automatically will push you back. Isn't it, guys? That's what always happens. The moment you say less than alpha, so sir, it will go towards the left now. But what is the issue here? The left is more probability because this is different from your normal XY axis, right? So here alpha is less on the right hand side. Again, Always remember, this is the distribution. You are not looking the x-axis now, buddy. You are looking on the y-axis, deciding on the x-axis. That's why it is confusing. You look at the probability on the y-axis, where the probability will be less as you come down now. Come towards the right or come towards the left. This is the highest probability, guys. This is the highest probability, this point. Clear? So that's why when you say P less than alpha, you reject. Less than equal to alpha, you reject. Because why do you reject also? Because it's a very unlikely observation. It's not normal, right? Again, I'll tie back to this diagram, right? A man kills his wife, right? Are we going to put here a man kills his wife? No, it's unlikely or likely. It's likely to kill a person? No. So I'll say a man doesn't kill his wife is likely to happen, right? And here it will be a man kills his wife. Unlikely. So now you understand why I say that not guilty is null hypothesis, because it is likely to happen. And being guilty is your alternate hypothesis, which will come here. Are we clear, guys? So if you observe, I have connected the dots. So now I will move on to the steps, typical steps in doing the hypothesis testing. The steps involved in hypothesis testing. So number one, null hypothesis means no change. It doesn't mean no assumption in. You are assuming that he has not killed his wife, right? It means natural, anything which has no change in the behavior, right? So if you take my example, killing a person is not a normal behavior, right? It's not natural, right? Got it? So if something is natural, no change, no effect, right? No cause effect, it's going to be null hypothesis. So number one point, how to get into hypothesis testing? So first of all, you have to formulate it, you have to assign which one is going to be null, which one is going to be alternate. So formulate two hypotheses for analysis. Once you have done it, we'll move on to draw sample. So once you have done the hypothesis statement, draw samples from population for analysis. Obviously, it is for analysis, why do you need to write? Third step will be perform appropriate test, perform appropriate statistical tests or techniques, right? There I'll teach you multiple techniques. Last step will be either accept or reject. Accept or reject. We don't even talk about alternate. We always talk about accept or reject null hypothesis based on evidence. So don't worry, I will take example in hands-on to show you this in action. Clear? Now guys, I'll talk about two types of error. So when you try to do hypothesis, you are bound to make mistake, and there can be type 1 versus type 2 error. You might have heard about this in statistics, hypothesis testing. You must have heard about type 1 versus type 2 error, very famous. So let me show you a nice diagram. Doesn't matter what you do, right? You are always going to make mistake. Chances will be less, but you are bound to make mistake. And the moment you make mistakes, right, you are going to get certain error. Okay. So first thing first, let me explain you what are these errors. So number one, if you see, you are going to see two normal distribution curve, right? And if you see here, if you take this curve as the base, which is your null hypothesis samples, right? And you are thinking it is null hypothesis part, but if you look at, this is your any mean value you have estimated, like, this will be equal to mu naught or mu one, whatever. Against this cutoff, can you see that against this line, you see something like this. See, so now if you look at this, this is known as type 1 error. Why it is type 1 error? Type 1 error is a type of error which happens when there is a rejection of null hypothesis, which is when it is actually true. So let me take in my example. Suppose a man is being tried for the murder of his wife and he was innocent. A man who is innocent got convicted in the trial for murder of his wife. What kind of error is this? Come on. This is your type 1 error. Generally, again, in the law and order, there's a philosophy that doesn't matter that if you set free some criminals, but make sure that you don't convict an innocent man, right? Have you heard of it? It's okay that you make mistake in punishing a criminal, but you cannot punish an innocent. But irony is that it happens a lot of time, right? Across the globe, but the idea is to avoid it. This is known as blunder. This is not an error, it's a blunder. You cannot go with this. Even in any machine learning model, type 1 error is not accepted at all. Okay? Means how can you do that? It's like you're telling a man you're pregnant. I'll show you that image also. You are telling a man that you're pregnant is a type 1 error. Let me show you that image. It's a very cool image. Generally, it comes as memes, right? Let me just pull that for you. Yeah. So this is the image which I was talking about. You must have seen it in a lot of data science memes. Yeah, this is much better. Although they are calling, true positive, true negative. I cannot go in that yet because that's more of a classification, ML based kind of understanding. But can you see that type 1 error? It's there in the box. What is type 1 error? You are looking at an old man. He's the doctor, and you are telling him that you are pregnant. Obviously, it's a blunder, right? You can look at a pregnant lady and you can say you are not pregnant. That's your type 2 error. That is still acceptable, right? It doesn't harm anybody, right? But how can you say this to a man? So then, this is a typical example of making an error, right? In null hypothesis. And can you see that this particular part of the tail is in null hypothesis? But since you are overlapping these two guys, null and alternate, and you have a cutoff of mean, anything more than this, you say it is null, it is rejected. So you have rejected the null hypothesis, right? Anything before this, now can you see that, guys? This one, you have accepted the null hypothesis. And there can be a chance that if you look at this part, hello, can there be a chance that this part is part of what another one, alternate also, right? Hello. So what's happening, guys? This is known as type 2 error. So far with me. So what is type 2 error? Type 2 error is the kind of error that occurs when we do not reject the null hypothesis equivalent to equivalent to false negative, and when the null hypothesis was false, right? So this is as good as saying, I need some space below it. I'll write here. This is like saying a man is proven not guilty. This also happens, by the way, even when he killed his wife, right? Are you getting, guys? This is equivalent to what error? Type 2 error. Type 2 error. Type 1 error, type 2 error. Right, guys, clear? As per the law and order, this is okay. Means I know you guys might be feeling, oh, how can you leave this person? But this is how it is. In case you make a mistake and a criminal gets free, it's okay. But an innocent cannot be convicted. Now I'll give you the definitions. So this is type 1 error. This is type 2 error. So type 1 error, when there is a rejection of null hypothesis, when it is actually true, and type 2 error, when we do not reject a null hypothesis, that is false. So this marks the closure of hypothesis testing, not from the example or use cases. This is more from the concept side. When I'll take this example in the hands-on, you can understand nicely.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
So when do we use t-test, guys? You have a jet test. Why do we need t-test? When the sample size is a little trouble for us, right? So when the sample size is less than 30, so your jet test will fail because jet test needs minimum 30 or more than 30 so that your distribution can be qualified as normal distribution. So then for small sample sizes, if you want to compare the group means, right, or compare the means of two groups, so there you go ahead and use the t-test. T-test is like a t-statistics, which is to find the difference between the two means or compare the two means. Okay. So let me give you this and we can discuss on this. So whenever you're comparing two samples means, right? So you are looking at a population. So this is your population, just imagine. And let's say you have two samples, sample one, and you have another sample, sample two. Now there can be two different population as well. So that's one of the way of looking at. You can have one population and you can have another population, pop one, pop two. You have two samples coming out of these two different populations. Now the question is that which t-test is being used where? This is known as paired t-test. This is known as paired t-test. Okay. And what you are looking at, the other one, this is known as if samples are taken from two independent population, two different population, this is known as two sample t-test. And this is something you have to keep in your head, means you can't do much about it. These are the concept. Okay. So when you're trying to compare the means, two means like this, you have a two sample t-test, you have a paired t-test. There's one more thing when you compare the mean against the standard value. So let me take a population, you are getting a sample out of it, sample, and you are comparing this sample against a standard value, then this becomes your one sample t-test. So now you don't have two samples, you have only one sample, right? And you are comparing against some standard value. Let's say I have a sample and I want to compare the sample mean against, let's say, 20, right? So that it will say that you are comparing with respect to 20, and that becomes your one sample t-test. Okay. So these are the different flavors of t-test. T-test works on the, as I was telling that when you have the sample less than 30, then only you should use t-test. And there are few assumptions, guys, like samples are independent. I just talked about homogeneity in sample variance, also known as homoscedasticity. It's a very difficult word to pronounce. Homoscedasticity and heteroscedasticity. Anybody recalls that? So homoscedasticity, let me use this word, means homogeneity of the variance. Can you see that? So whenever your all the samples, right, sample one, sample two are having the same variance, different samples exhibiting same variance, they are called homoscedasticity. Okay. So that's like more like, one assumption that we have to just check to apply t-test. And data is assumed to be normally distributed. So normal distribution, homogeneity in sample variance, and samples have to be independent. So these are some assumptions that you have to, follow, you have to comply, right? Now I'll get into more like a tree diagram. Suppose you are doing the hypothesis testing, you want to reach to a conclusion, and you are trying to do test. Now this tree diagram will help you guys, and this is about your population. Okay. So suppose you're doing hypothesis testing, right? And you know that in my, in my data, sigma is known. Okay, population variance is known, and n is greater than 30. Then you go ahead and use Z score or Z test. What is that? You remember I had taught. So you will take x bar sample mean, subtract population mean, divide by sigma by root under n. Okay, that's what we call Z test. Now, Z test will also be of two types. So let me extend this a little further. Z test is also going to be of two types, one sample and two samples. Just like I have mentioned about t-test. One sample, it will be compared against a standard value. Two sample will be compared against each other, right? This is what we call as Z test. Okay. I will show all these things in hands-on format as well when will we reach there. Now, what is X bar? Sample mean. Let's get familiarized. What is mu? Population mean. What is sigma? Population standard deviation. What is n? N is your sample size. Should be good. Give me a go ahead if you're clear about the formula and the bifurcation. If sigma is known and n is greater than 30, right, we will use that. This is all informative. We have to follow that. Means we cannot be questioning that how did it come. Definitely it has a history, but there's no point getting into it. Then on the second side, we have a t-test, right? For the t-test, you don't know the sigma, so you come with S. S is your sample standard deviation, and N is less than 30. These are the two criteria there, that you don't know the population, standard deviation. You know the S. S is your sample standard deviation. Let me write here. S is sample standard deviation. And if you look at the formula, you will try to, so S is known and N is less than 30, right? Then what you will do, again, you will use a flavor of Z test, which is going to be replaced. Yeah, going to replace your formula, which you have written Z. Now, since you don't have the sigma, what you will write? S by root under N. You have seen this as well. Okay. And this can also be one sample and two samples. Both are Z test only, guys. But the flavor is different, right? Now the question is that, can we apply this Z test, N is less than 30? Then people say that, okay, X bar minus mu, and why don't we name it something else? Because it is similar flavor of Z test, right? But can be called like a Z test, right? No. When N is less than 30, right, you will name it as the T test, right? But if you see the inspiration is from here only. So similar to Z test, but you are renaming it given that your requirement of the sample size, and you say that it is T test. Okay. See, the only thing which you are looking at this as differently, my dear, is the sample size, and S is known. You don't know the sigma. So your T test, what I've written here, you will observe that it is close to Z test. That's what I'm highlighting, nothing else. Okay. What is the name of symbol of standard deviation? So I've written now, see, X bar sample mean, mu is population mean, sigma is population standard deviation, S is your sample standard deviation, N is sample size. This is what we call also as student t-test. So by default, we say loosely t-test, or you will say student t-test. Clear? Now, moving on, there can be, sometimes people say, what is one tail, what is two tail, right? So let's understand that one-tailed versus two-tailed test. Okay. First, understand two-tailed test. Which you have seen yesterday, two-tailed test. So let me show you one nice diagram. So this is the two-tailed test where you say if the population mean is equal to sample. Can you see that? This is what we are saying. Population mean is equal to sample mean. That is going to be your natural hypothesis, right? Population mean is equal to sample mean. And here we are saying population mean is not equal. So guys, at the moment you say not equal, it can go in any direction. Say, if you say it is not equal, it can go either towards right-hand side, where it is, more than the population mean is more than the sample mean, or it can go to the negative direction, sorry, left side direction, when the population mean is less than sample mean. That's where you need, when you are trying to have hypothesis like this, you need a two-tailed test. You cannot do one tail. Why? Because you don't have a direction there. Do you have a direction that you will go towards left or right? No, it's bidirectional. It can go any direction. So for that, you have already seen me doing this study, the whole game, the same game, right? Alpha is, this is your rejection region, also known as significance level. This is where when you reject your null hypothesis, let me write, and this is for alpha equal to 0.05, which is your level of significance or significance level. And when you say that your probability value, p value, is less than equal to alpha, what do you do, my dear? Reject the null hypothesis, which basically means H naught. The moment you reject, either you will come here, this part of the chart, this is your rejection region. This region is known as what, my dear? 1 minus alpha, which is 95%. This is the reason where you will accept that your null hypothesis is true. Basically, you will say that your population mean is equal to sample mean. Let me shade. Then it will look real nice. Take a look at it, guys. Okay. Now this is two-tailed test. There can be another one, which is one tail. Now one tail test can be left or right, both. Because it's a directional one, right? So either you can go left or you can get right. Just for our reference, I'll use left. So when you say left, means your population mean is less than the sample mean. See, I'm saying, my dear, population mean is less than the sample mean. And alternate hypothesis is that null hypothesis is same only. Population mean is equal to sample mean. So now do you guys agree that, or you can see, it will be a one-tailed or two-tailed will be dependent totally on the way you are forming the hypothesis. You guys agree? Now this is known as left one-tailed test. So you can clearly see that the whole of the 5% is sitting here. Total acceptance region of 95%. Hello? Are we clear? And you can imagine the right hand will be what? Just opposite of it. Let me also quickly show you. So we'll see the rejection region on the right hand side. As you can see on the screen, see total 5%. But I just want to conclude that you are going to use Z test when your N is greater than 30, even equal to 30 will work, and population variance is known. Always remember that. Population variance is known means what? Sigma is known, right? You will always use t-test, student t-test, when N is less than 30 and population variance is unknown. That's why you use sample standard deviation. Clear? Now there are different t-tests, description about it. One sample if you're comparing it against a standard value, two sample if you're taken from two different population, right? And if the two samples are taken from the same population, right, you will use pair test. Okay. I'll give an example also. So I have a couple of examples to explain. I think that's what maybe someone is asking. One sample t-test, it tests whether the population mean of a single population is equal to a target value, right? Some target value. For example, mean height of female college student greater than 5.5 feet. So this is your standard or target value you are comparing against, right? That's your one sample. Two sample, when you say you are going to compare the difference between the means, right? See that? Of two independent population. So you say that, okay, you have a target value, but the target value is the difference between the means of two independent population. So then the example can be, does the mean height of female college student significantly differ from the mean height of the male college students, right? So there are two different colleges, right? One college is only for female students, right? So that's your sample. It is your female college, and you will take a sample called S1. Similarly, you have another sample, which is male college, and there you will extract another sample, and then you will compare the difference between the mean, right, using these two samples. Clear, guys? Got it? The difference between one sample, two sample? Perfect. Let's do a question, guys. The following data represents hemoglobin values in gram per deciliter for 10 patients. Okay. So number are 10.5, 9, 6.5, 8, 11, 7, 7.5, 8.5, 9.5, and 12. Question is the mean value for patients significantly differ from the mean value of general population? So guys, the data you are seeing is a sample, and the mean value of general population of hemoglobin is 12 gram per deciliter, right? At alpha equal to 0.05. My first question to you guys, look at this question and tell me that it is what kind of test you're going to do on this. So guys, you are going to do, since n is less than 30, how much is n? N is equal to 10. which is less than 30, and you have the sample compared against standard value of 12 gram per deciliter, right? So this gives me, combinedly, I can say, combining these two, it means I need to do one sample t-test. Okay, so let's do that now. So what is going to be x bar? And we know that n is 10, n is 10, x bar is what? Sample mean. So you have to do this sum of all these values. I'm not going to do till the last, and divide by 10. If you do that, guys, you can confirm it later. It will come out to be 8.95, right? Then we need to calculate the sample standard deviation. The formula is root under xi minus x bar whole square, I equal to 1 to n, divided by n minus 1. So basically it will be 10 and this will be 9. That's how you calculate sample standard deviation. Guys, if you do this maths, you will find 1.80. So what is your t statistics? X bar minus mu by s by root under n, 8.95 minus 12, 1.80 root under 10. Hands-on, you will be getting this as a result in 1 second or maximum 2 seconds. Python will do it. So now, guys, we have the t statistics value. What is it? Generally, what we do now, once we have the t stats, t statistic, we take mod of it. So if we take mod of, so I think I'm audible, right? So what you're doing, you're taking minus 5.35 and taking mod of it, right? Clear? So what you're doing, taking the t statistics and taking mod of it. There's a reason for it, and you will understand the moment I show you the t statistics table. Again, you will look at the table. Please focus. So this is the table, guys. And in this table, you will have a couple of things. One is your degree of freedom. That is nothing. That is n minus 1. So your sample size minus 1 is your degree of freedom. That is something you have to keep in your head. So tell me what is n minus 1. 10 minus 1 means 9, right? So we'll come here 9. Okay. Now it says that what is the critical value for this particular question? You have an alpha, which is 0.05. You have an n, which is n minus 1. So you have two things, or you need two things. Like, let me put it like this way. You have a degree of freedom, 9. You have an n, sorry, you have an alpha, 0.05. Looking at alpha and degree of freedom, what is alpha? This is your alpha. Now it is going to be one tail significance level or two tail significance level. It is going to be one sample, but what? One tail or two tail? You don't know which direction it will go, right? So you're going to take what? Two tail. It is not telling them more than or less than. It is just we are comparing whether it is equal to that or not, right? It's two tail. Within two tail, you will take alpha equal to 0.05. Tell me for degree of freedom 9. Yeah. Tell me for degree of freedom 9 and alpha equal to 0.05. Where you are intersecting, guys? You are intersecting a cell called 2.26. So it basically gives you the t critical value coming from the table, 2.26. What is the t stats? You have got it, t statistic. That is 5. Although it was minus 5. What was that, guys? Sorry. Minus 5.35. But since it's all in positive, we'll take a mod. So it is 5.35. Now, there's a condition that if your t statistic, and that's what you will learn step by. So I'll give the steps once you have these value steps. So number one step is what? Calculate t critical at given significance level of significance and degree of freedom from the above table, right? That's number one step. And you know that is coming, t critical coming 2.26. You have done it. Step number 2, if t critical is greater than calculated value, which we know as mod of t statistic, then what you will do, my dear, you will accept the null hypothesis. Maybe I'll use green. Accept the null hypothesis. Okay, that is 2 ka A. There can be a scenario where t critical is less than equal to calculated value T statistic, and then you will say reject the null hypothesis. If you compare this equation with this, remember, this you can compare like P is greater than alpha, and this is P is less than equal to alpha. Hello? This is just your reference point. Are we not saying the same thing, guys? Come on. Now let's look at the diagram also. So by the way, what is happening here? What, as per our question, what is happening? Your T critical is 2.26, T statistics is 5.35. Which one is what? Definitely T critical is less than equal to calculated value, right guys? Since T critical is less than T statistics mod, right? So what you will get, guys? The conclusion, you are going to reject the null hypothesis. So basically you are saying that sample mean is not equal to population mean. It is not a true reflection of that. And look at the values now. Your sample value came quite low, right? 8.95 sample mean. Look at the values, the different values, right? You have as high as 12, you have as low as 6.5, right? So that is definitely not putting you on that confidence that your sample is a true reflection of your population, and that's why you are going to reject it. Even you can visualize it, and you can also come to a conclusion from the T statistics, right? Now, if you try to put it into a understanding of the same distribution thing, right? So here, if you see, this is going to be two tails. So again, this will be 2.5%. This will going to be 2.5%. Let's say this is your T critical. What is that value? It's 2.26. So you know that your T critical is less than the T calculated value. T calculated value is what? 5.35. Although trust me, this is like, somewhere here minus 5.35. And this will be minus 2.26 symmetric. That's why I'm saying positive, negative. Isn't it? It is in this rejection region. You know that this is your rejection region. Or you can say that it is significant, statistically significant. That's why you're rejecting it. So we also say, right, this T statistic is what? In one way, we will also write it as statistically significant. Why it is statistically significant? Because it is higher than the critical values, and you will reject the null hypothesis. So basically, it is going to be in this. So this is known as what region? Rejection region or significant region? Significance region. I have shown you that. If you're not able to recall, let me go up and show you the diagram. See, it's there now. Rejection or significance level, right? I hope you are following here, right? See, look at me. I'm getting into the details of the things, right? I hope you can see that efforts, right? So are you feeling that okay, it makes sense, right? The statistical tests are making sense. Even for a smaller sample, you can make a judgment and it looks correct. Hello? Generally, when you do in Python, it will be just telling you one line. It will give you this T calculated, this number, and then it will say that whether you can accept or reject, and you reject. That's it. Behind the scene calculation, I'm showing. Guys, give me a good to go if you are following this. Rest others are going to follow the similar kind of style, right? So you see different behavior in the sample and the population. You might need to do a different sampling approach or something else, right? But this sample doesn't reflect the hemoglobin level for the population because it is significantly differ from the mean, right? So you can write a conclusion like that. So let me write also. So what is the conclusion? Sample significantly. So it significantly differ from the population, from the mean of the, I should write here, from the mean of the population hemoglobin. Let me find some more questions for you guys. I want to do a two sample t-test. Now, why don't you look at this? So it's a more like a MCQ question, guys. You have to choose one correct answer for it, right? So you have me or a restaurant owner wants to test if her two managers, so let's say it's an organization, it's a restaurant, right? And Mio wants to test her two managers perform at the same level, right? You're comparing two managers, whether they're performing at the same level or not. So what they're doing that she collects the data about the number of customer complaints at two random sample of shifts, right? So there are two managers working in two shifts, one for each manager, right? Right? In restaurant, people work in shift. Someone will start at 6 and they will go till, maybe 6 a.m. in the morning. So shift one can be 6 till 3 p.m. So 6 a.m. to 3 p.m. And another guy can come at another shift, which will be 3 p.m. till 12 in the night. Hello? So what she's doing, that she's collecting sample for this manager and this manager. Sample is all about number of customer complaints. Hello? So far with me, guys? And then the summary of the result they have given to you. So mean is 4 complaints, 5 complaints. Standard deviation is 0.3, 0.5. Number of shifts they have done 19 and 21. So this guy, she has collected for, let's say this is manager A. This is manager B. So how many shift data she has looked into? 19, and here she has looked into 21, right? 21 days or 21 shifts. In that, she is trying to come with the number of complaints. Now the question is, what you are going to use? Means how do you solve this? Do you have an idea? Definitely, this is going to be two sample T statistics. So guys, here you are going to do or use the statistics called T, and here you're going to use sample mean x1 bar, x2 bar. Here not you're going to write x bar minus mu, and then you're going to use this formula s1 square by n1 plus s2 square by n2. Okay, this is the formula we use all the time. Now, that's the reason that I am telling you this, because this formula can be derived, and I hope you know, right, everything here. X1 is, let me write. This is something you are not supposed to remember because you are going to code in Python, so you can easily use it, but you should write. This is like sample mean. This is sample mean 1, x2 bar, sample mean 2 for the second population sample. Then S1 is what? Sample standard deviation 1. S2 means sample standard deviation 2. N1 means sample size 1. And N2 means sample size 2. So when you do two sample t-tests, you do the difference between the mean. This is much important. So guys, 4 minus 5 you will do. So this is correct, this is correct, this is also correct. So definitely out of these options, these two are gone, right? Now standard deviation is what? 0.3 whole square. So I think this looks more closer, right? But tell me one thing. This is the very close, but why this 0 is coming? If you look at the exact formula now, there will be one more term which we generally assume as 0. So the formula says sample difference. Definitely it is x1 bar minus x2 bar. But you are also subtracting, well, there is one more difference, and that is known as hypothesized difference. So basically, I'm saying population difference, if there is anything, and then standard error of the difference divided by standard error of the difference. So what I have seen, people missing this, x1 minus x2 bar, mu1 minus mu2. So this mu1 minus mu2, if you think that the population mean difference is also there, this comes from the null hypothesis. If there is no difference in the population mean, then what you will set mu1 minus mu2? If there is no difference in the population means, it implies that you put mu1 minus mu2 equal to 0. That's how you put this equal to 0, and that's how this 0 is coming. Are we clear, guys? Denominator, no change. You will still write the same. S1 square N1, S2 square divided by N2. Comfortable? I hope you like this question, right? It's easy. Then you can do a number of things. So if someone can calculate this T statistics quickly for me, what is that? 5 minus 4, 4 minus 5. Do the maths, anybody? Root under 0.3 whole square by 19, 0.4 whole square by 21, 0.5. What is the T statistics you have gotten? minus 14.46. And degree of freedom you have to also take now. So see, N1 is equal to 19, N2 equal to 21. So you know degree of freedom will be what? N1 minus 1 plus N2 minus 1. So actually it comes out to be N1, N2 minus 2, right? So how much is that, guys? 40 minus 2, 38. And alpha, if nothing is given, you can always take 0.05. Okay? I'm just confirming my degree of freedom. Let me open my notes. I think it is N1 plus N2 by minus 2 bits. That's correct only. So this is your degree of freedom. Now look at the table. I know this is 38. I don't know we'll have 38 in this. No. But T stats df equal to 38, alpha equal to 0.05. It's very tough. Generally, you should not get worried because I think sometimes these things trouble us, but that's fine. There's a website called Mera Calculator, significance level 0.05. You can calculate this. That will give the critical value. Guys, what is the value for that? So see, this is a calculator for critical value. I have taken two tail 0.05, 38 is my degree of freedom. So that gives me this value. What is this value, guys? So T critical comes out to be, please help me here. It is 2.0249. What is my T statistics mod? Minus 14.46. Earlier you told me how much. Someone can also confirm that. Nobody is calculating, but I assume that this is what, but I don't want to assume. That's what the problem is. Leave it. 0.3, 0.5, right? These are the values. 0.3, 0.5, 19, and 21, right? So my equation is 0.3 into 0.3 divided by 19. I'll just do this. I'm using Excel, by the way, in case you're wondering what he is doing. This plus this, and I'll do square root this, and then I'll divide minus 1 by this number. It comes minus 7.7518. It comes minus 7.7518. Why you are getting so many different values? Minus 7.7518 period. That should be the value. Why you are getting different values? What's going on? Upload calculation नहीं कर सकते. So it will be 7.751. Definitely you can see that it is higher, so you will reject null hypothesis. That's it. Clear? I think this is what I'm looking at the table, getting it. So what you are saying that definitely there's a significant difference in the manager performance level because they're not same, right? Which one is better, which one is not, that is a different question. Okay. So now guys, next thing we can look at is the F test. Okay. So I'm putting the heading F test. So F test is more to look at the variance of two populations, right? Not the mean. So when you want to compare the variances of two populations, you are going to come to F test. Okay. And there are a few assumptions similar to like T test, normal distribution of the data is independent. So generally when you are trying to do the F test, what you do, you try to check if my screen is up, right? If the variances of the two populations, where the groups are taken from equal or not, where the groups are taken from equal or not. So there are, two population, you have extracted two sample. Let me draw. This is gen population 1, this is pop 2, and you are extracting a sample 1, or group 1, and sample 2. So what you do, you try to estimate using two samples that the variances for the two populations are same or not. Are you able to understand, guys? What you're comparing? You're comparing the variances are same or not. Earlier you were comparing the means, remember? So what will be your null hypothesis? So null hypothesis can be variances are equal, and alternate hypothesis is, that variances are not equal. Okay, null hypothesis, and this is your alternate hypothesis. Once you have it, then you calculate the value of F. And what is the formula we deploy? It is larger sample variance. Which one is larger? You will put it on the numerator, divided by smaller sample variance. That is sigma 1 square divided by sigma 2 whole square. Okay. And then degree of freedom you need. And that is going to be, there will be 2 degree of freedom, df1 and df2, because of 2 populations. So because of 2 sample, n1 minus 1 and n2 minus 1. Okay. It's very easy, guys. Trust me, it's more easier than t-test. This is the distribution table for F test. Can you see that? Now you have a degree of freedom 1, see, and you have a degree of freedom 2. Let's say for any of those, let's say hypothetically, your degree of freedom is 1 is 8 and another is 12, let's say. So where you will reach finally, guys, come on. What is your T critical? 2 point whatever this. What is this number? 2.50 maybe. So where you are intersecting, guys, 2.50196, that becomes your F critical. And then again, the same game. You will compare, they will try to, come to a conclusion. It is also known as, F test is also known as variance ratio distribution test, right? Some fancy name, but you have it. Trust me, there are a lot of distribution. One of the distribution is F distribution, okay? But the problem is that we cannot get into too much of the distribution also. That's not in the scope of the syllabus. But you have a T distribution, you have a F distribution. So the sky is the limit. You have a chi-square distribution, right? There are quite a few distributions. But our aim is to, look at F distribution and try to get into any of those kind of analysis. But rather than looking too much into distribution, our focus is directly look into the, the test, and so that you can handle it. Okay, I think so. See, formula derivation, if you try to do, then you will get a little out of the place. Okay. Any sample limit, I think no. As you can see the notes, we are not talking about n has to be less than or more than, right? So you can use it. And this table is for different alpha, guys. So just one thing I missed to write is that this table which I've given now, this is for alpha 90%. So 0.10. You can also have alpha for 0.05 like that. So this is a very good website which you can look at it for the table. So for different alpha, different table is there, and you can leverage that. Okay.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Okay. So let me put the heading ANOVA. So ANOVA is another statistical test, guys. So let me share this and talk through. So ANOVA, also known as analysis of variance. See, till now we were only compare means variance between two groups, right? Either you were doing one sample or you were doing two sample. Let's see if I ask that if I want to compare between more than two or more groups, and I want to compare the mean, what method I should go with? Because these will not allow me, right? So that's where ANOVA comes into the picture. Although the name is analysis of variance, but it tries to compare the mean of different groups to understand that, how one group is significantly different from the other group. Clear? Again, then we have certain assumptions that samples needs to be independent, right? The another one is very important, that all populations should have common variance, right? Homozygosity. And samples are drawn from the normally distributed population. Okay. So ANOVA, there are different types of ANOVA, but the one which is we are going to cover in the syllabus is, let's say, one-way ANOVA. So one-way ANOVA is basically an extension of t-test, right? So for example, you have population 1, population 2, and you can go till end population K. So you will observe that you have how many groups? You have total K groups. So here the idea is that, if I want to find the difference between the means, right, I'll follow an approach which will help us to, find the variation among the sample means. So everyone will have a sample coming out of it, sample 1, sample 2, and sample K. So just for the three groups, right, let's say for K equal to 3, I can show you one diagram, see that if that makes sense. So look at here. So this is how the different populations are varying. But do you notice one thing, that all these guys are having similar variance, right? The length of this arrow. So the one first thing you should observe that the three populations have the same variance, the common variance. Although their mean are significantly different from each other, but if you compare the means between these two guys, sorry for the very blurred photo, but it is very helpful. That's why I'm using it. So if you look at this, can you quickly see that there's not much difference between these two? So mu1 and mu2 are look closer. However, they are significantly different from mu3. Can I say that, guys? So there are three population, 1, 2, 3, having three different means, and you're trying to compare it. Okay. So once you have a fair idea about that, what it does, why don't we get into the calculation, the approach? How do you do it? Okay. So let me give you the F statistics for this. So how they calculate, guys, they will use F and they'll try to find variation among sample means and normalize it with the natural variation, or you can just write variation within groups. Okay. So, or you can write, mean sum of squares between the groups, mean square of errors, which is MSC, and mean sum of square between the groups is known as MSP. So finally, it boils down to, MSP by MSC. Just keep that in head. And we are going to deep dive on this. So let's understand first thing first, what is MSP? So as the nomenclature suggests, that it is mean square between groups. Okay. So how do we calculate it, guys? There's a formula called SSB K minus 1. Suppose you have K population, we'll do K minus 1. Okay. There's a formula, you can't do anything, you have to keep that in your head, but I'll explain it later. So you actually write xj minus x bar whole square. You not understand much here, guys. I'm telling you, you just note down the formula and then here you write nj. Okay. That's your MSP, which is SSB by K minus 1. We have another one called MSE, mean square of errors. I'm going to explain, but first let me give you the formula. So this is going to be SSE, sum of square error, n minus k. So basically it is sigma nj minus 1, nj minus 1, then another sigma x minus xj bar whole square, okay, n minus. So it comes to sigma nj minus 1, and this comes to sj square n minus k. So basically this n, which is you are seeing, is known as total number of observations throughout k groups. This is like the big total. So let's get into an example, okay? Because we need to calculate this in the, in a very simple step-by-step approach. Ideally, end of this exercise, you will be trying to create this table, which I call ANOVA table, source of variation. Some of the things you have not gotten yet, I know that, so please don't worry, just follow through. I'll explain with the example. Between groups, this is your error, and this is your total. The three segment, if you see. Now, number one thing, we have to calculate sum of squares. So you already know you have to calculate SSB between groups. Error will be SSE. So this is something, it is Nj SSB. On the top I have written Xj bar minus X bar whole square. Okay. Nj Xj bar. Guys, I missed the bar here. Xj bar minus X bar whole square. Okay. Xj bar minus X bar whole square. Okay. SSE is double sigma X minus Xj bar whole square. Total is SST, which is SSB plus SSC. Then you need a degree of freedom. So number one is DF1, K minus 1, DF2, N minus K, DF3, N minus 1. Okay. Mean squares. So MSB equal to SSB, K minus 1, MSC, SSC by N minus K. Okay. Then finally, we'll calculate F value, which is the ratio, MSP by MSE. Okay. So I know this is a little overwhelming, I think, but let me try to explain you by taking an example, and I think you will get it. I don't see any reason that you not get it. So let's say I have a table which says that times required by 3 workers to perform an assembly line. So they are working in an industry. Assembly line tasks were recorded on 5 selected occasions. So let's say we are the people. So this is first worker is me, second worker is, let's say, Dilip, third is Pratika. Okay, let's say. So now let's say these are the numbers, guys. 8, 8, 10. Okay. 10, 9, 9, 9, 9, 10. Okay. 11, 8, 11, 10, 10, 9. Yeah. So these are the 5 days on the 5 selected occasion. 1, 2, 3. So far with me with the data, guys. And this is all in hours, okay? So let's say 8 hours, 10 hours, 9 hours, 11 hours, like that. So now tell me, there are 3 groups. Maybe I can give you 3 colors. Okay? That's why I'm coming to Excel. You like it, the way I teach this. The 3 population, 3 sample, right? If I ask you what is the sample average, what is the sample average? So I think you know, right? What you will write quickly? Average of what? Each of these kinds, 9.6. You find sample for Dilip, we'll do 8.8 and Vertica is 9. This is your sample average. What is sample variance? So you know that it will be variance and this will be S for sample. See 1.3, 0.7 and 0.7. Okay. Now there can be overall average also. And that will be what? Average of not across the population. It is going to be the average of the whole guy across the total N, right? So how much is that value? 9. Now also tell me what is the value of N and what is the value of K. N is to like what? How many total? 50. And how many groups are there? 3. Good. Now we need to calculate sum of square between the groups. How will you find sum of square between the groups? What is the formula says for sum of square between the groups? It says that you will use Nj, and let me write, and the beauty about Excel is that I can write also. So maybe I can write here. Nice. Doesn't disappoint me. What is SSB? SSB is equal to sigma Nj Xj bar minus X bar whole square. Okay. So guys, let's understand that. What is the meaning of Nj? Nj is number of data points within each sample, which I had not written there. Now I'm writing. Nj is what? Number of data points within each sample. Okay. What about Xj? This is your sample mean. And what is this X bar? There is no J means overall mean. We'll say this as overall mean. And you know the numbers also, right? So sample mean is how much? This is what going to be the sample average. I'm giving the arrow because I like giving it. Sample average and overall mean is this number, guys. Good. Now SSB we can calculate. So first thing first, how many number of, it is 5 into, now you have to write Nj minus. So this 5 into sample mean 9.6 minus overall mean, right? Whole square. I hope you know a little bit of Excel. Plus, you will do the same thing again. You'll write 5 into 9.6 minus 9.4 whole square plus 5 into, not unusual, the next group, this minus 9.4 whole square plus 5 into 9.8 minus 9.4 whole square, and that will give me the value of sample mean. Sum of square between that. Right, guys? So far with me? So this is your sum of square within the groups. That's why you're doing, right? 9.4, 9.4 all the time. So this is known as variation between the groups. Now I need to find sum of square error, which is actually within the group itself. So for that, what is my approach? Approach is very simple. I'll do n minus k, right? Sorry, nj minus 1. So it is going to be, right? Remember the formula, nj minus 1. Let me write the formula. What is sum of square error? It is sigma nj minus 1 into sj square. So variance. That's it. For now, you have to follow this. Okay. So let's calculate this equal to nj minus 1. So each group has equal number of samples. This is a very simple case. So you do 5 minus 1 into C12. What is C12, guys? For me, it is variance, right? I have calculated it now. What is Sj square, guys? Your individual variance plus 5 minus 1. Then I'll do this variance, 5 minus 1. Are you guys following with me? Then you are doing this variance. Done. 10.8. So you have the variance already calculated within sample variance, right? Remember, what is this Sj square? This is your within sample variance, right? So that gives you SSE. So what is your SST? Sum of these guys. So what is it? You will sum it up 10.8 plus 2.8, 13.6. That's your total. Okay. This is SSB, SSE, SST. This is not your MSB. So to get into MSB, remember I had given a formula. To get into MSB and MSE, you have to use a formula. And let me show you what is that. You have to divide it by k minus 1 in 1, and 1 you have to divide by n minus k. So ideally, MSB and MSE will calculate by the division. Remember, what is the division? You will take this SSB and divide by k minus 1. What is k? 3 minus 1. So how much is that? 1.4. SSB is what? This divided by what? N minus k. 15 minus k. Remember? That gives you, what did I do? I7. Let me rewrite. Sorry, guys, something I missed. This value at 7 divided by n minus k. Right? Perfect. This is cool. Now you tell me now, what is the value of f? It is the ratio of MSB by MSC. 1.556. Wow. Now, once you have the f statistics value, right, what you will do? We need to find something, right? So what we will do? You have f statistics. What is going to be your f critical? Calculate it now. So f critical is going to be calculated. So this is what you have calculated is known as f statistics. Remember? And that is coming 1.555, whatever, 1.55. F critical is what you will find, and that's going to be a question mark for us. Now you have to use a certain rule. So first number alpha is 0.05. One of the degree of freedom is k minus 1. Another of the degree freedom is n minus k. So this is equal to 3 minus 1, our case 2, and this is equal to n. N is 15 minus 3 is 12, right? And you will be looking at a table. And this is what I have to show to you. Maybe I'll write here. Wow, this is good. So guys, tell me degree of freedom. So this is between the groups. So it will come here, right? And one is it will come here. And then you will draw a line and compare. Where are you able to circle it up, guys? Here, 3.89. This is the F table for the degree of freedom for the significant alpha level 0.05. So now you tell me your F stat is what? Less than the F critical. What do you do in this case? Accept the, nothing changes. Accept the null hypothesis. So, and what was the null hypothesis? That your means are not significantly different. So, what means that the means are more or less close. And let's see that. One of the mean is 9.6, one of the mean is 8.8 and 9.8. So, it's not significantly different. You might be wondering, is there a way that you can show that the other case, right? What I'll do now, guys, I'll just copy paste the whole thing. And that's the beauty about Excel. You can just replicate in nanoseconds. See, you have to just update it that, okay, Akash is very hardworking, as you know. I'm just kidding, right? I'll just put some weird numbers like he's working 18 hours in 24 hours, right? So definitely I'm in line to beat Narendra Modi, our PM. Can you see that, guys? My F statistic is 21 point something. Now, if you see, tell me, again, get back. So what is the value of critical? Critical will not change, now, because it depends on the alpha and blah, 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 right? So what is the value of F critical? It is, what was that, 3.89. What is the F stat? What do you see? So you see that F stat is more than F critical. So what? Reject. Reject means you say that the difference in the mean, in the sample means, is significant. Are you feeling it, guys? So what I have made you learn today, and now I can see that you can understand, and give me a word if you are with me, that looking at, so for, when I gave you those mathematical sigma and all, I know a lot of people are from non-mathematical background. So for me, it's like back of my hand. I can do like this. But for you, it can be tricky. That's where I, strategically weighted you, put you on hold that, okay, come to this table and then you suddenly understand. Can you see the question, guys? A pharmaceutical company conducts experiment to test the effect of new cholesterol medication. Very much required. It's a real pharma question. The company selects 15 subjects randomly from a larger population. Each subject is randomly assigned to one of the 3 treatment groups. Within each treatment group, subject receive a different dose of new medication. In group, whatever they have given, 0 mg per day, 50 mg second day, and 100 mg per day. So actually they're telling, my dear, is this, that first group 0 mg, group 2 50 mg, group 3 100 mg, medication difference. After 30 days, doctor measured the cholesterol level of each subject and the results for 50 subjects appear in this table, right? Definitely these are cholesterol values, okay? In conducting this experiment, the experiment had 2 research questions. Does doses level have a significant effect on cholesterol? It's a very obvious question, guys, right? Second, how strong is the effect of doses level on cholesterol? So about significance and the degree of strong. Right, 210 to 40. What is that? 270, 270, 300, right? So now you tell me what is the, obviously the color formatting has gone. 3 groups, and here you go, right? So you can clearly see that the average is what? 258. I'm just making sure that N is 15, K is 3. Overall average looks correct, right? So it's coming 4.16. Okay. So we have F equal to 4.16. And we know that F critical is what? We have already calculated that 3.89 at 0.05. So we know the maths. What is it? F statistics comes out to be 4.16. F critical is 3.8. It was no 3.89. So definitely F statistic is more than F critical. So it is going to be reject the null hypothesis, right? Definitely it looks meaningful that, right, the different doses will have different impact on the cholesterol level, right? Can you see that? So they differ. See, different mg will impact on the cholesterol level differently. and look at the sample average. It looks that 210 is little better. So 100 mg medicine is making your cholesterol level little lower, guys, isn't it? Means we have a view, right? 260 and 210. Definitely there is quite a difference. You cannot say these. See, you can say more or less these are similar range, but it does impact. So if I have to put a visual, so I can say that, hello, you have 0 mg, you have, what do you mean by 0 mg? 50 mg, 100 mg. So you have cholesterol level 258. You come here, you have a cholesterol level 238 and 246. And then you come here, you see that your cholesterol level has come down to 210. And this is like, guys, not from 0. This is like, let's say 150 range to this one. Can you see that you have a downward trend coming down? Not like drastically, but it does come down. Hello. I have done this so that you can feel this coming down slightly, but it is coming down. Okay. So guys, we are going to import certain libraries, like, import numpy as np, import pandas as pd. These are standard ones. Import operating system for working directory. Import matplotlib dot pyplot as plt. Import cbon as sns. Right? Cool. This should work. Yeah. These are the libraries, guys. Please type in so that you have it ready. Now we will start with first test, which is our Z test. Okay. So from SciPy, import stats. So SciPy is science py. So I'll ask you to install this, means call, not install. So guys, let's start with one sample Z test. Okay. So you know that one sample Z test, if I can give you a point, you know that what it does, checks whether the sample comes from a known population, right? Remember, where population mean and standard deviation sigma should be known, right? Right. So I need to find certain data to do this. Just wondering which one to take. Okay. So do you recall, right? One sample Z test we do to do what? Just to give you a flashback. So let's say you have let us say that you have a sample data and you want to test. I'm writing in plain English. You want to test if the sample mean is significantly. You don't need to type. I type fast because I do it all the time. Different from the population mean. That's why do you do this? That's the reason for you doing it, right, guys? Come on. So what I'm going to do, I'm going to just create a sample data, like you just type in a list. So sample, I can give number 3, 4, 5, 6, 4, 6, 4, 6, 5, 4, 6, 3, 5. Okay. And let's say the population mean and standard deviation I assume is this. Follow me. So I say that population mean is pop mean 4.5 and population SD standard deviation is 1.2. Okay, there are two variables I have created, guys. Now I'm going to perform one sample Z test. So for that, what I'll do, I'll write Z statistics. So there are two multivariable I'm creating, guys, and P value. And then I'm going to use my function stats dot Z test sample is my sample. Then I need to give value. It has no attribute called Z test. Really? Import SciPy as stats. Maybe this is another one we should use. So guys, it's also in SciPy only. SciPy little big one, right? SciPy stats as stats. Okay, let's run it. Now I think you should get interesting. Hold on. Stats dot z okay. They have updated z statistics, they're called. But this is not the z statistic. This is to my variable name now. Z score. Hold on, guys. I'm missing the formula. Is it z score or not? Okay. So the z test one, which I was trying to do, guys, it seems that it's not working out for us. Okay. So guys, the reason is that I was not importing maybe the right libraries. So we have to import from stats, the models, stats, that's why it's missing. Maybe let's see that. Wait, stats, import z test. Wow. Now it will work, guys. So we have to call, I'm giving two value, to be honest, z score and p value, and I'll say just z test. Simply, right? Yeah, it picked up sample, and value will be equal to population mean, pop mean, and pop standard deviation. Okay. And let's see, did it do anything? Oh, I missed one thing, na? My bad. Sigma is equal to pop. Now see, sigma is not there. Value, alternative, 0, use variance, pooled. But how can we, it's 0. Guys, let me do one thing. I'll do away from this, because this approach, this library is not helping me anything. Okay, here. So what I'm going to do, I'm going to install another library. It's not a very good one, which I was trying to do. So it is known as bioinfo kit. Okay. Okay, perfect. Now what you have to do, you have to call this bioinfo kit dot analyst import. This is to get data. So you can also get some data, which is inbuilt data for doing Z sample, one sample Z test. So to give you some background about this data, forget about the data I was looking at, because that's anyway some mocked up data. Now let's come to this data. So guys, this is to get sample data for understanding the statistical test. Okay. Now let's say I have a data, which I get it from this function, get data. So this is the function you're calling, get data, and there you will call Z1 sample. You have to write Z1 sample, and you have to say data. This is the way you get data, guys. Okay. Wow, perfect. This works, right? So it's a data frame, right? And if you see, it is a series, right? It is only one column, it's a series. Now this data is, guys, it's a factory data. Let me talk about a little bit more about the data. So I can give a factory produces, the tennis balls of diameter of 5 centimeter, but due to manufacturing condition, every ball may not have exactly the same diameter. Then the standard deviation they are telling of the balls is 0.4. Now the quality officer would like to test whether the ball diameter is significantly different from 5 centimeter in a sample of 50 balls randomly taken from the manufacturing line. So did you understand the problem, guys? There is a factory which manufactures the tennis balls, right? The ideal size is 5 meter. So they have taken a sample from the population, right? So let's say you have a lot of tennis balls. You have taken a sample which is of size 50, right? And these samples you are going to use for the one sample one sample Z test, because your sample size is greater than 30, and you are going to say that, okay, whether your sample size mean is equal to 5 or not. That's the sample z test you will do. Okay. So now, guys, once you have the data, what you can do, you're going to use the z-test function available in the bioinfokit library. So to do that, you have to import from bioinfokit.analyst import stat. So first you imported the data, now you're importing the function, and then you will call the function using rest. You can put some result result dot z test. Now z test needs a data frame number one. Suppose you have your own data, you can also run it, right? So you have to give a data frame x equal to your column name. What is the name of the column? Just go on the top and read sizes. So you'll put the sizes. It's there. And then you have a mu. So what is the population mean you want to compare against? 5. And what is your x underscore standard deviation? That is 0.4. And test type is equal to 1. One sample is test type 1. So see, pandas data frame containing X group. X is the column name for the X group. Mu is your, hypothesized or known population mean. Standard deviation for the group. Alpha you can also set, and type of Z test, use one for one sample Z test. The moment you run this now, you are done. And then you can print the result summary by using the function result summary. And you will be happy to see the output. And if you look at the output given by SciPy library, right? Let's say, for example, I show you one sample Z test SciPy stats output. Let's see. Right? So they calculate the Z score, guys. I don't know if they've given some example, but look at that. No, this is not the Z test. One sample, yeah. It seems to be this one is Z test. It's a T test. First of all, finding the Z test has become like something, I don't know why they are not able to do. But anyway, but if you say this is the T test they're doing, and if you look at the output, can you see the result? Look at that. This result is like very lame. See, Z test, T test, same now. So T test result, look at that. The result we get in our function, look at this. So structured. You can take a screenshot and you'll go. So first thing first, it shows sample size 50, mean 5.0176, Z value is 0.317. And now they're giving p-value for one tail, two tail, lower, upper, everything. Is the p-value significant? What is the concept? Concept says if your p-value is less than alpha, you reject. Less than equal to alpha, you reject. What? Null. If your p-value, don't forget the basics, is greater than alpha, accept. Remember that? Now tell me, for alpha 0.05, which is our standard, what is the p-value you are getting? 0.75. Even one tail is 0.37. So it is p is greater than alpha. So are you going to accept the null hypothesis or reject? Accept, right? So what is the interpretation, my dear? So interpretation is I'll write p-value obtained from the one sample Z test. One sample Z test is not significant, and you can write. I hope you understand. Okay, but do you think it's an important tool for the quality managers? Think about it. Is it practical for any quality manager that okay, you open every tennis boxes ball and try to check, right? It's impossible. So what they do, they take the batches of production and they will take sample and they will run a Z test, right? And if they are statistically they are getting this, what we have gotten, they'll say, okay, pass. They are not going to check each and every ball, right? They will just, obviously, they'll check each and every ball in the sample, not in the population, and then try to quickly, estimate against the population and say that, okay, it is not significantly different from the ball sizes which I need to produce. So I'm more than happy to pass your batch. So that's the whole cycle goes through here, right? Okay.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.